Hello everyone, and welcome to Creating Scratch and Win Game with the Unity course. My name is Alex Jurik, and I am visual effect artist and game developer for around 5 years, and together we will be creating this popular game genre. Through this course, we will be using new universal render pipeline, and we will start by creating simple background shader with a Unity shader graph, which will be later modified to support scratching. Then I will show you how to draw smooth lines inside Unity and also how to calculate scratching progress. We will also learn how to save and load the data of our game. Then we will be also programming very cool animation system which doesn't need any animator or animation controller, and we will easily preview our animations inside editor. At the end, we will build our game for a mobile phone. Together, we will learn a lot of advanced stuff which you can use in your own games. So I hope you will like this course, so please join me and I will see you in a class. To start, let's create a new 2D project inside Unity and let's call it Scratch It Game. And let's press Create. Let's open the package manager. And let's import universal render pipeline because we will be using it through this project. Now inside hierarchy, let's create canvas. Let's change the render mode to screen space camera. And let's drag and drop our camera on it. Change plane distance to 11. Now inside canvas scaler, let's modify UI scale mode to scale with screen size. And I am basically choosing my phone resolution, which is 1440 and 2560. And let's change the match value to 0.5. So the UI will try to adjust even if our real resolution will be completely different. Now let's create new UI image. Let's change the anchors to be stretched by pressing Alt and clicking on corner icon. Let's change the colors so we will have the same background. Let's add aspect ratio feature component. Change aspect mode to envelope parent and aspect ratio to 1. So our image will be always inside the parent, but still it will be always squared. Now inside the assets, let's create a new folder. And let's call it materials and shaders. Now let's create new material. And let's call it UI tileable. And also let's create new unlit graph shader and let's call it with the same name. Now let's select the material and let's assign our UI tileable shader, which will be inside shader graph folder. And let's assign the material into the UI image. But now we have a problem because our shader is completely pink, and it is because we didn't set up our universal render pipeline. So let's do it now. Click on Edit and let's choose Project Settings and let's dock it to our right window. Click on Graphics and here we need to choose our render pipeline asset. So let's create a new folder and let's call it Rendering. And inside, let's create new rendering, universal render pipeline, and pipeline asset. Now let's assign our render asset into project settings. And let's start to create our material. So double click on our UI tileable shader. And let's click on shader graph window, which just appeared. And let's press Shift and space together. And the shader graph window will maximize. First, we would like to create some vignette element of the shader. So let's create UV node. then distance node, and let's connect it to the port B, and also let's create vector2 node, and let's connect it to the port A, and let's change the x value to 0.5 and the y value to 0.5, and we see we have a nice circle which we can use as a vignette. Now let's create one minus node, so we will inverse the result, create add node, and by changing it, it will increase the vignette scale. Now inside Blackboard, let's create new vector1 property, and let's call it vignette scale. And let's connect it to the port A of the add node. Now let's create new power node. And by changing the port B, we are changing the intensity of the vignette. So let's create new vector1 property, and let's call it vignette intensity. And let's drag and drop it to the scene. Let's connect it to the port B, and let's change the default value to 1. Now let's add the last node, which will be the saturate, which basically clamps every value between 0 and 1, so we will not have any weird results. And let's connect it to the color node. Let's save the asset, and inside the inspector we can see our shader is working. Now let's go back. Now let's create a subgraph from it, so we can reuse it later. And let's call it vignette. And let's reconnect our two properties, vignette scale and vignette intensity. And we finished our first small shader, and we will continue in a next lesson. Now to continue, we need something which can tile our textures. So first let's create sample texture 2D node. And let's add new texture 2D property. And let's call it pattern. Let's connect it to our sample 2D node. And we can choose, for example, drop down a row sprite. Now we want our shader to support the rotating of the tilings. So let's add rotate node. And we can see it is working, but to expose we need to add degrees to radians node connected to the rotation input. And let's add new vector1 property called pattern rotation and connect it to our degrees to radians. Also, we want from our shader to support scaling of the tilings. So let's create tiling and offset node, and let's connect it to our UV node from the rotate input. Create new vector1 property, and let's call it pattern scale. And let's connect it to our tiling input. Let's try some scale numbers, but we see our texture didn't tile. So to fix it, let's create new sampler state node, and let's connect it to our sampler input. Now to connect our vignette with our tilings, let's create multiply node. And let's connect them together to our color main node. Let's save the asset, and we can test it inside editor. Let's assign the same texture to the pattern. And we can see the rotation, the scale is working, but our UI image color is not working. So let's go back to shader graph. Now let's create vertex color node, which is representing the image color. Then let's create one minus node, and let's connect it to the alpha output of the texture. Now let's create add node, so we can also modify the texture intensity. And in our Blackboard, let's create new vector1 property called pattern opacity and connect it to our add node. And to finish it, let's connect the saturate node to the output of the add node. And the last step will be lerp, which will basically blend our tileable texture with our vertex color. So let's connect them together. And let's also connect them to the multiply node. Save the asset and let's check it inside the editor. And now we can see our image color is also changing the material color. Also, we can see the opacity of the pattern is working. Now let's try something. Let's create a new panel. Let's make it a little bit smaller. Let's assign the UI sprite. And now we have the image type sliced. And let's change the pixel per unit multiplier for 0.04. And let's assign our UI tileable material. And we can see the UVs are kind of bad, and also the sprite doesn't cut the alpha. So let's fix it. Let's open our material, and to fix it, we need to create new texture property, and let's change the reference name to underscore main text. And also let's change the exposed value to be off. And what the main text is doing is basically referencing the UI sprite with the alpha, so we can use it in our own material. So let's drag and drop it to the scene. Let's create new sample texture 2D node, and let's connect them. And also let's connect them to the alpha of our unlit master node. Now let's save the asset and test it in editor. And we can see the alpha cutout is working, but now we still need to fix our UVs. And to fix them, we can create position node, and let's change the space to object, and let's connect it to our tiling and offset node. Save the node and let's check it in the editor. And now we can see our tiling is completely bad. But let's change the pattern scale to some very small value like 0.003, and we can see now our pattern is working again. But there is a small drawback. Even it looks like it is in object space, when we are using it inside UI, it works like in word space. But for our tileable background texture, it really doesn't matter. Now let's go back to shader graph and let's create subgraph of our tileable part. So let's select all the tileable nodes. And let's click on convert to subgraph. And let's save it as tileable OS. Now we need to reconnect all the properties from our Blackboard. Let's save the asset. The last thing we can fix is the error which we get. So let's open the vignette subgraph and let's add the saturate node. And let's connect them between add node and the power node. Let's save it. Let's go back to the editor and we can see the error is gone. Now let's import proper texture, which will be in course resources for this lecture. Let's make cleanup of our directories. Let's put everything related to rendering under rendering folder. Now select our material and let's put the texture we imported to the pattern. Now delete the panel because we don't need it anymore. Now let's put the final values into our shader. So let's change vignette scale to 0.25, vignette intensity to 2.4, pattern rotation to 45, pattern scale to 0.01, and the last thing, pattern opacity to 0.77. The last step is to change the name of the image to BG, And we finish nice background with tileable texture for our game. So thank you and see you in the next lesson. Now we need to create a drawing system. So let's create a new folder. Let's call it scripts. And inside let's create another folder and let's call it managers. And inside let's create a new C# script and let's call it drawing manager. Let's open it. Let's clean the file. Now we will be using some event systems. So we need to import the namespace. Now let's add iDragHandler interface. So when we click our mouse onto the UI image and when we start dragging, the event will be recognized. So let's implement it. Let's delete the throw exception. Let's write draw method with the event data as a parameter, but first we need to create it. So let's write public void draw and let's put pointer event data as a parameter. And let's check if our raycast is correct. So it's not uploaded the screen or somewhere. So let's write if event data.pointer current raycast is valid equals to true. And if yes, we will add our position to the list. So let's create the list. So let's write list of vectors with the name positions equals new list of vectors. And back in the if statement, let's write position.add and let's put event data.pointer current raycast.world position. So all positions will be stored in a position list. Now to show this position, we can simply write onDrawGizmos and let's loop over the positions with a for each loop. Let's set the color of the gizmos to be yellow and also let's draw the sphere with the position parameter and the radius of 0.15. Now for better readability, I am using Supercharger. It is a Visual Studio extension, but unfortunately it is paid extension, but you don't need it if you don't want it. Let's save the code and let's go back to scene. Let's click on background. Because we are using in our script UI events, we can drag and drop our drawing manager into our BG image and all events will be recognized correctly. And let's try it. And how we are drawing, we see the small gizmo spheres. So everything is working. Now for drawing the line, let's create a new effect and line renderer. Let's first reset the transform. And in our script, we will be instantiating it. So let's create a new folder called prefab. And let's drag and drop our line to it. And let's delete the line game object. Now let's go back to the script. And let's create new variables. First will be public game object line renderer prefab. And the second will be private line renderer current line renderer. Now inside our if statement of the draw method, let's write another if statement. So if current line renderer equals null, let's call a new method called createLine with the same point with the event data as parameter. So we need to create this method. And in this method, we will be setting the current line renderer. And also we need to change the 2 points which are defining the line. So let's write current line renderer equals instantiate line renderer prefab, and we will get line renderer component from it. Now to set the point, let's write current line renderer dot set position, and inside let's write 0 for the first point, and the actual position will be new vector 3, and the x value will be event data dot pointer current raycast dot world position dot x. Our y value will be event data dot pointer current raycast dot world position dot y, and our z position will be 0. Let's select the line and copy it for the second point and just change the index to be 1. So we have 2 points with the same position for our line. Now inside our draw function, and let's write an else branch. Basically, when we already have the line renderer, so we would like to update the position. So let's write update line position with the event data as a parameter. And let's create a method. Now inside the method, we need to increase position count of our line renderer. So let's write current line renderer dot position count equals current line renderer dot position count plus 1. And now we need to set this position, which is basically always the last position. And let's put the last index, which is basically current line renderer dot position count minus 1. And let's copy and paste our vector tree from the function above. Now we need to initialize also the current line renderer when we start dragging. And we can do it with another event. So let's add iBegin drag handler, and also let's implement it. Let's delete the system exception, and let's write current line renderer equals null. So always when we start dragging, our current line renderer will be null. So now save the script and let's go back to scene. Let's fill the drawing manager with our line prefab. Now let's test it. And we see the line, but let's change it a little bit. So let's open the prefab and let's change the width to be 1. But let's also change material. So let's create new material and call it solid color. We need to create also the shader. So let's create another unlit graph. And let's call it again solid color. Select our material again. Add our shader to our material. Select the shader and let's open it. And let's create new vertex color and just connect it to our color. Save the asset. Inside our prefab, select a line game object. Assign the material into our prefab. Now we can change the color of the line renderer. Let's exit the prefab and let's try it. And we can see it's working much better. Now we can tweak it even more. Open our line prefab again. And let's change corner vertices and end cap vertices to 10. And now the drawings are much smoother. But there is a small problem. When you draw very fast, we can see the corner vertices doesn't work good. So we can fix it in a different way. Instead of drawing one line renderer per each dragging, we can split it into multiple small line renderers, and we don't need the corner vertices at all. Let's open our drawing manager. And let's add one line into our update line position method, which will be basically create line with the same point. So when we are updating point, we are also creating new line renderer. Now let's try it. It's working nicely because as we see, we have a lot of line renderers, and when we see the wireframe, we see that each line renderer is only a small part, so our brush stroke will be always nice and round. Now let's add one more thing. We would like to have possibility to delete all the line renderers, so we need to store them into the array. So let's write public list of type line renderer with the name myLineInstances equals to new list of line renderer, and we will add this line to the create line with the same point method. So let's write myLineInstances.add and let's add current renderer, and to delete them let's write new method public void clear instances, and inside let's loop over the list of the line instances, and we need to write destroy item.gameObject because we don't want to destroy only the line renderer, but also the game object on it. And to finish it, we need to clear the list of position and also list of mainline instances. And to test it from editor, we can just add a context menu attribute and let's put the clear instances as a name. Let's save it. Let's start drawing. And let's go to our drawing manager component. Now we can see the clear instances method and we can click on it and it will delete all the line renderers. So that's all for this lesson. Thank you and I'll see you in the next one. So to create scratchable material, first let's import the assets for this lesson. On the canvas, let's create new empty game object and let's name it panel. Make it a little bit bigger. And from the imported folder called prefab for import, let's drag and drop the scratching part under the panel. Now let's unpack the prefab completely and now we can delete the folder. Now when we open it, there is a lot of UI images, but it's very basic setup. And inside the image, we are using these two sprites, which is panel edge and panel fill. So you can check it yourself. Now for the making the scratchable material, we need to create a projection camera. So let's duplicate our camera and let's call it projection camera. Let's delete the audio listener. Let's change the background color to be white. Let's change the output target to texture. And inside textures, let's create new render texture. And let's call it scratch render texture. And change the size to 1000 times 1000 pixels. And let's assign the render texture to texture variable. Now let's click on the camera and let's add one more layer with the name scratching. And what we want is to assign this layer to our line prefab. So let's open the line prefab and let's change the layer to scratching. And what we want is basically render our scratching layer with our projection camera. So let's change the culling mask. First click on nothing and then click on scratching layer. And then we also need from our main camera to not render this layer. So let's do it. And now when we try it, we are seeing the line renderer inside editor, but we don't see it inside gameplay. But when we check our texture, the texture is written correctly. So that's exactly what we want. Now let's create new material. Let's call it UI main scratching area. And let's create new unlit graph shader. Let's call it UI scratch shader. Let's assign it to our material. Now we can open it. Let's maximize the window. Create new sample texture 2D node. And let's create new texture 2D variable inside Blackboard. Let's call it render texture. And let's assign it to the sample texture node. Now we need to invert the alpha. So let's create one minus node. Let's connect it to the sample texture node. And let's connect it together with the unlit master alpha. Now let's create vertex color and simple connect it to the color of our unlit master node. Let's save it. Now let's assign our material into image and assign render texture. And let's try it. We can see it's doing something, but not exactly what we want. So let's fix it. Let's create new UVs. So let's create position node and let's plug it into UVs. Now let's try it. Now it seems better, but it's still not what we want. The UI is composed differently than other game objects. So basically we need to scale up the UVs. So let's create tiling and offset node. Let's plug it to UVs and let's plug that one to our sample texture. And we need a vector1 node, which we will plug into our tilings. And we need to scale down our tiling to 0.1. And how I got the number 0.1? We can get it by dividing 1 by 2 times of camera size. And our camera size is 5, so we are dividing 1 by 10, which is exactly 0.1. Now to continue, let's change the offset to be in the middle. Save the file. And now it works exactly how we want. Let's open the material again. We would like to create the edge when we are scratching, so the scratching alpha will have the edge. So let's duplicate our sample texture 2D node. Let's create new tiling and offset. Let's move it a little bit. And let's plug our old tiling and offset to the UVs input. And now we need to offset these UVs a little bit with a vector1. And let's create new property called edge width with the default value 0.05. And let's connect it to our vector1. And to make it work, we need to subtract the alpha of our offsetted edge with our new alpha. And let's plug the saturate to clamp it between 0 and 1. Now to add the color, let's create the layers node. And let's connect the saturate to it. And also let's connect our vertex color. Let's create a new color property and let's call it edge color. And let's change it to red color and connect it to our port B of the layer node. And now let's connect the layer node to the color input of our unlit master node. Let's save it. Let's try it now. And we can see our edge is starting to work, but we need to do it with 3 more axes. So let's duplicate our sample texture 2D node 3 more times. Let's duplicate our tiling and offset node 3 more times as well. Let's connect them together. Let's connect our main tiling and offset node. Now we would like to change the offset to be negative. So let's create multiply node. And let's change the port B to -1. And let's connect it to our vector1. So now one axis is working. Let's create the second one. Let's create vector2 node. And let's duplicate the multiply node and connect it to port B to our vector node. And let's connect them together with our vector1 node. Let's duplicate our vector2 node again. And let's duplicate our multiply node again, but now let's connect them to port A of the vector2 node, and let's connect vector1 together with multiply and vector2. Now we are changing offsets in 4 axes, so we need to combine them together. Let's duplicate the subtract node 3 more times. And let's connect them with our copied sample texture nodes. Now to combine them together, let's use the add node and let's make 3 of them. Now just connect the subtracts together and 2 add nodes together. To finish, let's connect the last add node to the saturate node. And at the end, don't forget to connect our render texture. Now let's save it and let's try it. And we see we are having nice edge. Let's change the width and it's working nicely. Now let's go back to material and let's implement our vignette and our tileable subgraphs. So let's import them. Now we need to recreate all the properties. So let's create vector1, vignette scale. Connect it. Let's use default value of 0.01. Let's create another vector1 and let's call it vignette intensity. Let's connect it. Change the default value to 1. Create another vector1 and call it pattern opacity. Connect that one. Change the default value to 0.5. Now let's create texture 2D property and let's call it pattern. Connect it. Now create another vector1 property and call it pattern rotation. Another vector1 called pattern scale. Change the default value to 0.01. And the last one will be texture 2D property. And let's change the reference name to underscore main text. And also change the exposed to be off so we can have nice cutted alpha from our sprite. And now to connect it together, we need a multiply node. And let's connect our output from vignette with our pattern color output. Now we don't need the vertex color, so let's delete it and connect our multiplier output with the lerp. Now we need to combine also the alpha channels. So let's create another multiply node. Let's connect our tileable alpha with our 1 minus alpha. And let's connect them together with our unlit master. Save the asset. Let's modify our material a little bit. So let's assign our pattern texture. So let's change pattern opacity to 0.45. Let's change pattern rotation to 45. Let's change edge color to be white. And now let's try it. And we can see the scratching is working perfectly and it's exactly what we wanted. So to have better scene readability, let's create some separators, create new game object, and let's fill it with the equal symbols. And let's duplicate 3 more times. Let's save the scene. And that's everything for this lesson. So thank you and I'll see you in the next one. Now we will be creating samples, and by them we will be basically detecting if we scratch some part of the image. So let's first disable the panel. Then select canvas and let's create new empty game object. Let's rename it to sample and let's create another UI image under it. And let's stretch it. Change the color. Now let's drag and drop the sample game object into our prefab folder. Now under the canvas, let's create another empty game object and let's call it board piece. And let's change the width and height to 300. Under board image, create another game object and let's call it samples. It's a place where we will be store all the samples of our board image. Make it stretched. Under it, create another game object called vertical. Also make it stretchable. And let's add new vertical layout group component. And let's change control child size, width and height enabled. And let's change spacing to 5. Create another empty object and let's call it horizontal. Add the horizontal layout group. Again, change spacing to 5 and control child size, width and height to true. Now let's drag and drop our sample under the horizontal game object and let's duplicate it 2 more times. And we can see nice rows. And then duplicate the horizontal game object 2 more times and we have nice grid layout from our samples. Now inside script folder, create new folder and let's name it board. And inside create new C# script and let's call it sample. Let's open it. Clean the file. Now we need to use Unity Engine.ui namespace, and let's write private image my image, and let's create awake function, and inside let's write my image equals to get component of type image. So when we add the sample component under UI image, the my image variable will be filled automatically inside awake method. Then we need method to enable the sample. So let's write public void enable sample with a bool value parameter, and we will be enabling it by calling myImage.raycastTarget equals to value. By setting the raycast target, we are basically telling to UI event system if our image is visible to it or not. Then let's create another method called public void visit sample. So basically, when we drag our mouse over the sample, we want to turn it off. So first, let's disable it. And also to see it visually, let's write myImage.color equals to color.clear. So basically, our sample will disappear. Now to enable our samples for testing, let's enable them inside awake method. Save the file. Now let's open the drawing manager. And here, let's write private void raycastMe with a pointer even data parameter. So by this method, we will be basically detecting the sample. Now to detect the sample, let's write even data.pointer current raycast.gameObject.try get component, and we need to use out and sample my sample as parameter. That's how we are writing new try get component method, and we need to put it to the if statement. Inside we write mySample.visitSample. So basically, if the UI image have the sample component, we will visit it. Now let's put this method inside create line with same point. So basically, every time when we are creating new point on the line, we are also raycasting the samples. To visually see where we are basically raycasting, let's put our position array inside the raycastMe method. So our position gizmos will be stored there. Let's save the file. Let's go back to editor. Now let's open the sample prefab. Select the image. And let's add our sample component on it. To try it, press play. And now when we are drawing and we pass over the samples, they are disappearing because basically we are visiting them. So this is working nicely. But the problem is that our line has some thickness and we are detecting the samples only from the center points of the line. And to fix this problem easily, let's just increase the scale of the samples. So let's open the sample prefab, select the image game object, and change the scale to 3. And we see our samples are overlapping now. Now let's test it. So press play. And when we are drawing, the raycasting doesn't work as intended because it is only hitting the samples which are on the top of the other samples. So basically overlapping samples are not detected. So to prevent it, let's open the drawing manager, and inside the raycastMe method, let's create new list with the raycast result with the name results equals new list of raycast result, and we will be filling this list from the another method. So let's write event system.current.raycastAll, and let's put even data and the result as a parameter. And now let's create for each loop, and we will be looping through results. Now let's copy our if statement and let's put it inside the for each loop, and let's delete even data.pointer current raycast and replace it with the result. Now fix the typo. And also we need to be sure our results are exactly in a points where we want them to be. Let's put our position array inside our for each loop and change the even data dot pointer current raycast with the result. So now our gizmos will exactly show the raycast position. Let's save the file and let's go back to editor, press play. Now let's try to draw. And we see it's working nicely. All the samples are detected. Now let's do the test. Let's really quickly draw the line from the beginning till the end of the image. And we see we didn't get any samples visited. And that's because our raycast missed the image completely. So to fix it, we need to kind of divide this line when the distance between two raycasts is too big. So let's open the drawing manager script, and inside a draw method, inside the else statement, we need to detect first the alt position. So let's write vertex 3 alt position equals to current line render dot get position 0. Now we want to store the current position. So let's write vector 3 current position equals to even data dot pointer current raycast dot word position. Now we have the alt and current position, and after our line position, let's first calculate the heading direction of these vectors. So let's write vector 3 heading equals to current position minus alt position. Now to calculate the distance, let's write flow distance equals to heading dot magnitude. And the last thing we need is to calculate direction. So let's write vector 3 direction equals to heading dot normalized. Now we need to define minimal distance. So let's write float min distance equals to 0.5. And we need to check if distance is more or equals to min distance. Now we need to detect how many of these points we want to resample. So let's write float how many raycasts equals to distance divide min distance. Now let's create for loop from e equals 0 to e is less than how many raycasts. And inside, let's write vector 3 raycast position equals to all position plus, now let's use the brackets and let's write directions multiply I multiply min distance. So now we calculated new subsampled positions, and to pass these new positions to the raycast, we just need to alter even the data position. So let's write even data dot position equals to, and now we just need to convert our word position into screen position, and the easiest way is to do it through camera, and luckily our even data have a camera variable inside it. So let's write even data dot enter event camera dot world to screen point, and let's put our raycast position as a parameter. And the last thing, let's call our raycast_me method. Now to see the list of the resampled position, let's duplicate our old position list and let's create new one called resampled positions. Now let's change our raycast_me method a little bit to have bool resampled parameter with a default value of false, and inside for each loop, let's check if resampled is true. And if yes, let's add to our resampled positions the result.word position. And if not, let's create else statement and it will be the old one. Now to see it visually, let's duplicate our for each loop from the onDraw gizmos, change the name to resampled positions, change the color to blue and change the radius to 0.1. One more thing, we also need to clear our resampled position when we call clear instances. So let's duplicate the old positions.clear and let's change it with resampled positions. And the last thing, we need also add the resampled true into our raycast_me method. And our method above is working good because it has default value of false. Let's save it. Now press play and let's try to draw a really fast line again. And we can see that we nicely subsampled the positions and all the samples are detected. So that's everything for this lesson. So thank you and I'll see you in the next one. Now we will be creating the board image, but first we need to import the TextMesh Pro. So let's open project settings. Let's dock them to our right window. And let's import TextMesh Pro Essentials. Now we can import package. And let's select our board image package. And let's import all the files. And we imported a lot of sprites, which we will be using as a board images. Now let's open the canvas, open the board piece. And from our prefabs for import folder, let's drag and drop our board image prefab onto our board piece. Now we can unpack the prefab completely because we don't need it anymore. And let's delete prefabs for import folder. Now we can have a look into our imported board image, and it is very basic setup. First, it is our splash image as a background. Then we will have a main image. Under main image, we have also the text because we will be later doing bonus component. And under it, we have two circles, which we will be animating later, and they are acting as masks. So to zoom it a little bit, we see the rings inside our horseshoe image. For example, when we disable image and we enable text, and let's update the mask. When we zoom in, our text also have the masking. Just change auto size to be on and we are good to go. Now let's turn off the text again and let's turn on the main image. Now after our tweaks, let's create prefab from our board image. So let's drag and drop it into the prefab folder. And also let's create prefab from the board piece because we will be using it later. Now let's open our board image prefab. And inside script folder under board, let's create new C# script called board image. Let's open it. Clear the file. First, let's create a new public transform variable called samples parent, where we will be plugging the parent of our samples. Then to store the samples to the list, let's create private list of the sample type called all samples, and let's initialize it. Now let's create awake method, and let's write all samples equals samples parent dot get components in children of the type sample, and because it is a list, we can just write to list, but we need to use link namespace. Now let's open the sample script, and here we need to add private board image my board image variable, so all samples will have access to their board image. And to set board image, let's create method public void setBoardImage with the board image as a parameter, and let's assign our main board image to the board image variable. Now back inside board image script, inside our awake method, let's loop over all samples and let's assign the board image. We can shorten it into one line. Now let's save the file, go back to sample script. And from visit sample, we need to call new method from board image, which will be called calculate progress. But the method doesn't exist yet inside board image. So let's copy the name and let's create it into our board image. And by this method, we will be basically calculating the progress so we can decide if our board image is revealed and basically finished. So let's write if statement, and we need to check if our board image is already finished. So let's create public bool is finished equals false variable. Let's ask is finished equals to false, and if our board image is still not finished, we can increase the visited samples. So first let's create a private int visited samples variable, which will equals to 0. And inside our if statement, let's increase them by 1 because each sample will call this method, so it will increase the samples. And then let's create another variable with the type of float with the name current progress. And the current progress will equals to visited samples divided by all samples.count. Now our visited samples are integers, so we need to cast them as a float. And now we can finally check if our current progress is more or equals to 0.6. Basically like 60% of samples are revealed. And that's basically enough to finish this board image. So we can first change isFinished variable to be true. And now we can also finish all the samples of this board image because we don't need them anymore. So let's write a new method called visit all samples. And let's also create it. And inside the method, let's create for each loop, which will be looping all our samples. And let's call item.visitSample. So now all the samples are visited. Save the file. Let's go back to samples. And we can see inside awake method, we are enabling samples by default, but we would like to control it in a different way. So let's disable them. Now back inside board image script. Now let's shorten our visit all samples method a little bit into one line. And we can copy and paste it. And let's call it enable samples with a bool value parameter. And let's call item.enableSample with a value as a parameter. Now to call it temporarily from editor, let's write public void enable from editor. And let's call enable samples equals true. But to call this method from editor, let's write context menu as an attribute with the name enable. Let's save the file. Now inside board image prefab, click on board image and let's add our board image component on it. Let's go out from our prefab. Now we can fill the samples parent variable. So let's select the samples and drag and drop them into the variable. And also we see that our prefab is changed by a small blue rectangle. So let's right click on the sample parent and let's press apply override in prefabbed board piece. So now the board piece prefab is also updated. And when we create new one, these settings will be stored inside already. Now let's open the debug log to see our private variables. And let's press play. First, let's enable samples. And let's start drawing. And we see our current progress is increasing. And when we pass 60%, all samples are visited, so they disappear, and our board image is finished. So that's everything for this lesson. So thank you, and I'll see you in the next one. In this video, we will be creating a ticket section, which will be grouping our board images, and basically it will be one winning part of a ticket. So first, let's activate the panel. Change the width to 1000 to be square. Let's rename the panel to ticket section. Now select canvas and let's create new empty game object and let's rename it to ticket section parent. And let's drag and drop our ticket section under it. Now under ticket section, let's create new empty game object and let's rename that one to board elements. Change the rect transform to be stretched. Now move our board elements on top. Let's select our ticket section parent and let's create prefab of it. Now inside board elements, we will be creating something like the grid layout, but we will be using a vertical and horizontal layout group. So let's do it. Let's create new game object. Now let's call it vertical. Change the rect transform to be stretched. And let's add vertical layout group component. Let's check control size, width and height and change the child alignment to be center. Under vertical, let's create another empty game object and let's rename it to horizontal. Let's add a horizontal layout group component and let's check control child size, width and height and change child alignment to be middle center. Now let's drag and drop our board image under the horizontal game object. and we can see it's stretched. Now let's zoom in and out a little bit so the board piece will be visible. It is hiding the stretching part inside a scene view because of scene camera clipping planes, but we can take advantage of it. And now let's change the board piece scale to 0.6 in all axes. And let's apply changes to the prefab. Now let's duplicate the board image 2 more times and select the horizontal game object and also duplicate that one 2 more times. And now we have a nice grid of the board images. Now let's select the script folder. Inside let's select the board folder and let's create new C# script and call it ticket section. Let's open it. Let's clean the file. And let's write public list with the type of board image with the name board image list. Let's create a wake method, and here we will assign the board image list, which will equal to get components in children with the type of board image. And let's create a list of it with the toList method, which we can use by using a link namespace. Then let's create a coroutine. So let's write public IEnumerator wait until scratching finish. Now, what is a coroutine? It is a special method which can run over multiple frames. Now, inside our coroutine, we first need to wait until our ticket section will be finished. So let's write while section finished equals to false. We will be looping over and over every frame until our section finished will be finally true. And that's the advantage of the coroutine. We can do it easily just by writing yield return null. But we don't have our section finish variable, so let's fix it. Let's write public bool section finished equals to false. Now, after the while loop, we know that our section is finished already. So what we can do is to loop all board images, and we can give a signal to each board image to be finished as well by writing item.isFinished equals true. Now we would like to also enable samples from our ticket section. So let's go back to board image script and let's delete the editor one. And back inside ticket section, inside our coroutine, let's call enable samples with the true as parameter. But we don't have this method yet, so let's implement it. Let's write private void enable samples with a bool value as a parameter. And inside, let's loop over our board image list with a for each loop, and let's call on each board image enable samples with a true as parameter. Now we need to find out how we will be defining when our section is finished. So let's write public void update all count. But first we need to create a variable called private int finished board images count, which will equals to 0. And now inside our update all count, we will be increasing this value by 1. And finally, we will ask if finish board image count equals to board image list count. And if yes, we know all our board images are finished, so we can finalize also our section with the section finished to be true. Now let's go back to our board image, and to be able to call this update all count from the board image, we first need to define our ticket section variable in each of the board image. So let's create new public ticket section variable with the name myTicketSection. And we don't want to see it inside inspector, so let's create the attribute with the name hide in inspector. Now inside calculate progress method, we just write myTicketSection.update all count. Now, when we finish every board image, we will also call update all count method inside our ticket section, so we can count the finished board images and we can decide if our section is finished as well. Now back in ticket section, Now we need to assign ticket section to the board image. So let's do it inside awake method. So let's loop over all board images and let's assign to my ticket section variable this ticket section. And let's simplify it into one line. And the last step will be to create start method, where we'll be starting our coroutine. So let's write start coroutine and let's put our wait until scratching finished method there. Save the file and let's test it inside inspector. Press play. Let's turn on a debug mode. Let's start drawing and let's check our ticket section. We can see our finished board images are increasing. And when the number is 9, our section finished variable will be true. So that's everything. Thank you, and I'll see you in the next lesson. In this video, we will be creating a ticket which consists of 2 ticket areas. So first, let's select the canvas and let's create new empty game object. Let's rename it to ticket A. Change the rect transform to be stretched. Now let's change the anchors roughly in the similar size. Let's zero out the left, right, top, bottom, down. Now let's add a component, vertical layout group. And let's click on control child size, width and height. Change spacing to 40. Now select our ticket section parent and drag and drop it under our ticket A game object. And also select our ticket section and let's change our rect transform also to be stretched. And let's save the rect transform to the prefab. Now, to keep the square rectangle, let's add aspect ratio fitter and let's change aspect mode to fit in parent and aspect ratio to 1. Now we have nice squared image again. Now select our ticket section parent and let's create duplicate of it. Change the name to ticket section parent bonus. Let's open the board elements, open the vertical, and let's delete the last 2 horizontal game objects. Now let's open horizontal game object and let's delete the last board piece. Select our ticket section and change our aspect ratio to be 3. So now our section is rectangular. To fix the squared one to be the same width and the bonus one, let's select ticket section parent and let's add layout element and check the flexible height and change it to 3. So now our both section parts are the same width. Now the last thing, select our second board piece and change it to board piece text. Let's open it, open the board image, open the image main and select it. And let's turn off the image component, select the text, and let's turn on the text. Let's update the mask by turning it on and off. So this text field can be used for our bonus section to show how much we win or if we didn't have any luck. Now to have our bonus section a little bit different, let's also change our pattern texture. So let's import the package. Let's select bonus texture package and let's import it. And inside our textures folder, we can see how the pattern will look. And to create material, let's duplicate our UI main scratch area and rename it to UI bonus scratch area. Now open the scratching part, select the scratch image, and let's drag and drop our new material under the material property. Let's open it, select the pattern, and change it with our new image. Change the scale to 0.005. Now, to not forget this step, let's open our ticket section parent prefab. Select the scratching part and let's make a prefab of it. We will be using it later, but it's good to have it now. Now let's create our ticket script. So open the scripts folder, open the board folder, and let's create new C# script with the name ticket. Let's open it. And let's create public list of type ticket section with the name ticket areas. Let's create awake method and let's fill this list. So let's write ticket areas equals to get components in children with the type of ticket section, and let's make a list of it with the toList method. But we need to implement the link namespace first. Now let's create coroutine. So let's write public IEnumerator process one by one section. And because our ticket can have more scratching areas, let's loop over them. And what we want to call for each ticket area is their own coroutine wait until scratching finish. And what is happening when we are calling coroutine from inside another coroutine is similar thing that we are starting this nested coroutine, but the difference is that the parent coroutine needs to wait until this nested coroutine will be calculated, and then the parent coroutine can continue. So in our for each loop, it is behaving something like a playlist. So first we will start with a coroutine of the first ticket area, and after that one is finished, we will continue to the next one. Now inside our ticket section, let's delete the start method because we don't need it anymore. Inside our wait until scratching finish coroutine, let's create debug.log and let's write into console starting section. And the second parameter will be the game object. So then inside editor, we can click on this debug log and we can see which game object was calling it. And at the end, let's also write debug log section finished. Let's save it. Now let's go back to ticket. And let's create a start method. And here we will start coroutine and let's put process one by one section inside it. Let's save the file, go back to editor. Now inside our ticket game object, let's add our ticket component. Now press play. And let's start drawing. And we see our first section in a console starting. Now let's continue. And when we finish, we get the section finished log, and also the bonus section is also starting. And now it's finished. So everything works how it should. So that's it for this lesson. So thank you, and I'll see you in the next one. In this video, we will be fixing the problem with the drawing. So let's do a small test. Let's put our mouse cursor over our background image and let's start drawing. And we see the line appear and we are drawing normally. Now let's do the same thing, but let's put our cursor on top of our scratching area and let's try to start drawing, but there is no line appearing. So to fix it, let's first open the canvas, select our background image, and we need to move our drawing manager somewhere else. Select our sample scene, let's create a new game object. Let's call it managers. Inside, let's create another game object. And let's call it drawing manager. Open the background again. Press copy component and also remove component. And select our drawing manager and let's paste our component as new. Now let's open our drawing manager by double clicking on it. Now we know that our drawing manager is receiving the UI events, but now is no longer attached to any UI component. So let's delete our iDrag handler an iBeginDrag handler, but let's keep the methods inside, and we will be calling these methods from different UI events. And the best place is moving them to our scratching part. So let's open the scratching part prefab. Select our Scratch image. Inside the script folder, select the board, and let's create a new C# script. And let's call it scratching area. Open the script, clean the file. First, we need to use Unity Engine.event system namespace. And now we can add our UI events. So let's add iDrag handler and also iBeginDrag handler. Let's implement the interfaces, clean the exceptions. Now let's define public bool scratching enabled variable with a default value of false. And inside our onBeginDrag method, let's ask if our scratching enabled variable is equals to true. And if yes, we would like to call our methods from our drawing manager. So let's switch to our drawing manager and let's make it easily accessible with a static reference. So let's write public static drawing manager instance. And let's fill this instance inside an awake method where we are asking if instance is equal to null. And if yes, our instance will be this drawing manager. Now let's go back to our scratching area. Let's call our drawing manager by drawing manager.instance, and we want to use our old onBeginDrag method with the even data as a parameter. And inside our onDrag method, let's do the similar thing. Let's ask if our scratching enabled equals to true. First, we need to define public image, but we don't have the namespace, so let's first import Unity Engine.ui namespace, and let's name it Scratch image. And first, we need to change our Scratch image.raycast target equals to false. That means when we are dragging already on top of our Scratch image, we want to be invisible for the raycast, so we can pass the rays under it. And by that, we will call our drawing manager.instance.draw with the even data as parameter. And at the end, we can reset it to be again visible to the rays by scratchimage.raycast target to be true. Now let's create a awake method. And inside awake method, let's fill this scratch image by scratch image equals get component of image. Now let's go to ticket section script. And here let's create public scratching area, my scratching area. And we will be filling my scratch area inside an awake method. So let's write my scratch area equals to get component in children with the type scratching area. And let's put true as a parameter. And when we are using true as a parameter, the get component method will find our scratching area even if scratching area game object will be disabled. Now let's continue with the wait until scratching finish coroutine. So let's delete debug logs, we don't need them anymore. Then after we enable samples, we basically would like to enable also scratching. So let's write my scratch area.enable scratching. But this is a new method and we need to implement this functionality. So let's open our scratching area and let's write public void enable scratching. And inside we will just change our scratching enabled variable to be true. Now to visually see if our scratching is enabled, let's create new variable public color BG color. And when our scratching will be enabled, we will be changing scratch image color with our BG color. Now let's go to our ticket script. Let's create another method called public void finish processing. And let's put ticket section with the name section as a parameter. And we will be calling this method when each ticket section will be finished. And the first thing we would like to call is to finish our scratching area. So inside, let's write section.myScratchArea.finishProcessing. Now the method doesn't exist yet, so let's switch to our scratching area script. Let's write public void finish processing. And first, we would like to clear our drawing. So let's call drawingManager.instance.clearInstances. And also we would like to turn off our scratching area. So let's call GameObject.setActive to be false. Now let's go back to our ticket script. And inside process one by one section, let's add finish processing with the item as a parameter. Next, what we need is a method which will be preparing our ticket. So let's write public void prepare ticket. And here we will be first filling the section colors. So we can have different colors for each section. Let's generate this method. And inside the method, let's create for each loop, and we will be looping through all ticket areas. And we will be filling the color of scratching area. So let's write item.scratchArea.scratchImage.color equals to, and now let's go to editor and let's create a database script. So let's select scripts, and we need to create new script where we'll be storing these colors and other parameters. So let's create new folder and let's call it database. And inside, let's create new C# script and let's call it settings database. Let's open it, clean the file. And first we need to access it by static reference. So let's write public static settings database instance. And inside awake method, let's write if instance equals null, our instance equals to this settings database. Now let's create the color variable. Let's call it section enabled color. And for the disabled section, let's create another one with the name section disabled color. Let's add a header to the first color with the name section enabled color. And let's do the same to our second variable, and name will be section disabled color. So we will have nice separation of these variables inside inspector. Let's go back to our ticket script and let's continue. So let's write setting database.instance.section disabled color, because when we are preparing our ticket, all sections are by default disabled. And to fill our enabled color, let's write item.myscratchArea.bgcolor equals setting database.instance.section enabled color. Now let's go back to editor. Our errors are gone. Let's select our scratch image, select the board folder, and let's drag and drop our scratching area script on it. Now let's exit our prefab. Now let's create a new separator, move it under our managers, and let's create a new game object, and let's call it database. Select our database folder, and let's drag and drop our setting database component on it. You can also reset the transforms. And now change our section enabled color, so we have nice blue color. And change our section disabled color, so we have nice gray color. Now let's open our ticket script again. And let's put our prepare ticket method to the start method. So we are first preparing the ticket and then running the coroutine. Now to add a little pause so we can see how our section are being enabled, we can create yield return new wait for a second to our coroutine, and let's wait for 1 second. Let's go back to editor and let's press play. And we can see our section are initially disabled, and after 1 second, the first section is getting enabled. Now let's fix one thing. Let's open our scratching part prefab, select our scratch image, and let's turn on the raycast target so our scratching area can receive our UI dragging events. Now let's exit the prefab and let's press play. And now when we put cursor on top of our background image and we try to drawing, nothing happen, which is good. But when we try draw on top of our scratching area, it is working great now. But we have slight problem. When we draw over our second area, which should be disabled, we still can draw on it. But we will solve this problem in our next section, so let's see you there. In this lesson, we will fix our error where we can still draw on our disabled section. And we know the problem is only in a material. And here we will need to control the drawing by some value. And the easiest way will be to control it by our scratch image color alpha value. So if our alpha will be white, we can see a drawing, and if it will be black, we can't. Let's maximize our shader, and we need to do something like if alpha is 1, let's see the drawing, and if alpha is 0, let's not. And we can do something like if statement with a branch node. And we need two, one for color and one for alpha. Now let's connect the alpha value to the true, and let's connect the color value to the true of the second branch. Let's connect the branches to our unlit master node. Now we need to create the false branch, and false branch will be basically that we don't want to draw anything. So for the color, let's drag directly from our multiply node to the false input, and for the alpha, let's drag directly the tileable OS alpha output to our false input of our first branch, and the branches are finished. Now we just need to create an if condition. So let's create a comparison node. Let's connect its output to the both branches input. And what we want to compare is basically alpha value of our image. And we know that the UI image color we can access by a vertex color. So let's create vertex color node. And let's split the 4 values so we can have access to the alpha. And let's connect the alpha value to our comparison input. And we are asking if the alpha is equals to 0. And if yes, we are showing the scratching, and if not, we are not showing the scratching. Now let's test it. And we forgot something because we can also draw onto our second image. And we know we are defining our colors inside our database. So let's click on our database game object. So select our disabled color, and let's change the alpha to be 1. Now let's press play. And now we can see our second image is disabled for scratching. So that's exactly what we want. After it's enabled, we can scratch properly. So that's everything for this lesson. Thank you, and I'll see you in the next one. In this video, we will be creating an winning options for our ticket. So let's open the board folder, and let's create new C# script. And let's call it win settings. Let's open the file. First clean it. Let's remove the mono behavior because this will not be a component. On top, let's create a new public class called section price. And inside, let's add public int price and public float probability. And the price variable will define how much we can win. And the probability will define how big chance we have to win this prize. Now we need to define a prize types because we can win bonus points or money points. So for this, let's create public enum area type with the money and a bonus option. Now let's add system.serializable attributes to our classes so we can see the variables inside editor. Now inside the win settings class, let's add public section price called price preset. Then let's create public area type. Now let's create constructor for this class because we will be initializing this class from other scripts. And let's add underscore to constructor parameters. Now we can fix the constructor and we can delete this keyword. Then let's create public bool did I won variable, and we can calculate if we won directly inside our constructor. So let's write did I won equals to win or lose method, and the parameter will be price preset. Now we don't have win or lose method yet, so let's generate it. Let's delete the exception. First, to calculate if we win, we need some random number. So let's create float random number equals to random.range between 0 and 1. And to fix the red line error, let's delete the system.namespace, because the random.range is also inside Unity Engine namespace, so they fight together. Now to calculate if our ticket section is winning or not, let's ask if our random number is less than or equals to our price preset.probability, and if yes, let's return true, so the ticket section will be winning, or we will return false. Now let's go to ticket section, and now we need to add an option if the section will have money price or bonus price. So let's add public area type variable, and then let's add public win settings with the name win settings, where the win settings of this area will be stored. Now to fill these win settings, we need to create new method. So let's write public void fill win settings, and let's put area type as a parameter. Inside, let's ask if area type equals to area type.money, and if yes, and our win settings equals to, and we can use our constructor, so let's write new win settings. And before we fill the constructor parameters, let's duplicate this line for the bonus option and change the area type to bonus. And let's store our parameters for our win settings directly inside our setting database, so we can modify it very easily. So let's open the setting database, and let's write public list with the type of section price called money price list, and also public list of type section price called bonus price list. Let's add headers. First will be money prices, second will be bonus prices. Now let's go back to our ticket section, and let's fill the parameters. So let's write setting database.instance.moneyPriceList, and the second parameter will be area type.money. Let's do it also for our bonus part and change the area type to be bonus. Now we can see we are getting error for our first parameter, and it is because we are providing section price list instead of single section price. And to fix it, let's choose one random member from this list. So let's create new reusable method, which we can call also from other scripts. So let's go to our editor. So let's go to our script folder. Let's create utility folder. And let's create new C# script called utility. Let's open it. Delete the mono behavior because this will not be a component. Let's clean the file. And now let's create a new method where we put a list of any type, and we will get a random member from it. And these type of methods are called generic methods. So let's create public static t random from list of a type t, and let's put list of a type t as a parameter with the name generic list. And the t basically means that our list can have any type. And what we would like to return is basically generic list. And for choosing random member, let's write inside square brackets random.range between 0 and generic list.count. So let's go back to our ticket section, and let's fix our parameters. So first, let's add them into the round brackets, and then in front of them, let's write utility.random from list, and let's do it for both of them. And now the method is finished. So now let's go to our ticket script, and here we will be filling our winning settings inside the prepare ticket method. So let's write for each loop, where we'll be looping over our ticket areas, and let's write item.fill win settings, and let's put item.area type as a parameter. save the file, and we finish our lesson. So thank you, and I'll see you in the next one. In this lesson, we will continue with our winning options, and we will be creating winning panel. So always when we finish our winning ticket section, the winning panel appear and it shows us how much we won, and we can claim the prize by clicking on a button. So let's open the managers folder and let's create new C# script with the name win panel manager. Let's open it. Let's clean the file. First, let's create static reference to our win panel manager. So let's write public static win panel manager with the name instance. And inside awake method, let's fill our instance. So if instance equals to null, our instance equals to this win panel manager. Then we need coroutine for showing this winning panel. So let's write public IEnumerator show winning panel. And let's put win settings with the name win settings as a parameter. And inside let's ask if this ticket is winning. And we will do it with the if winning setting did I won equals to true. And if yes, we would like to enable winning panel game object. So first we need to define our game object variable. So let's write public game object winning panel. And inside our if statement, let's enable it with a winning panel dot set active to be true. Now we know that our panel will have text for the price and also image for the type of the price. So let's connect these UI elements with the method setWinningUI, and let's put win settings as parameter. Now let's generate this method. Let's delete the exception. Now for connecting image to show type of the price, let's create new image variable. And don't forget to add unityengine.ui namespace. And the name will be winTypeImage. And for showing price text, let's create new public TextMeshPro UGUI variable. And also we need to add tmpro namespace. And let's call it price text. And now we can connect them inside setWinningsUI method. So let's write price text.text equals to winsettings.pricePreset.price.toString. And let's ask if winsettings.type equals to areaType.money, then the winTypeImage.sprite will be the money sprite, and we can define the money sprite inside the settings database script. So let's switch to it and let's create public sprite bonus sprite and also public sprite money sprite. Let's also add headers attributes with the name bonus sprite and money sprite. Now let's go back to our win panel manager and let's continue. So our winTypeImage.sprite will equals to settings database.instance.moneysprite. And for our second option, let's copy the line and let's change area type to be bonus and our sprite to be bonus sprite. We know that our winning panel will have a button, and we can also use it to finish our coroutine. So let's create public bool clicked variable with a default value of false. And then inside our coroutine, because we will be showing our winning panel multiple times, let's always start with a clicked variable to be false. Now let's create a while loop, and we will be looping while our clicked value will be false, and we will be basically looping yield return null. In other words, we will be waiting until our clicked variable will be true. And when it happens, that means when we click on the button, we would like to disable our winning panel game object by writing winningpanel.setActive to be false. Now, when we start our game, we also need to our winning panel be disabled at the beginning. So inside awake method, let's also write winningpanel.setActive to be false. And the last method we need is to change our clicked variable from the button. So let's write public void winPanelClicked and inside let's write clicked equals to true. Now let's go to the ticket, and inside finish processing we would like to show the winning panel. So let's write yield return win panel manager.instance.show winning panel, and we need to add win settings to the parameter because our show winning panel will need it. And we also need to change a return type of our method to be IEnumerator, so we can use it as a coroutine. And then inside process 1x1 section, we can call it with a yield return, with the item as a first parameter and item.winning settings as a second parameter. Now let's go back to editor. Now let's open our manager's game object and let's create a new one. And let's call it win panel manager. Now let's drag and drop our win panel manager component on it. Now let's import our win panel prefab. So let's import new package and select win panel. And let's import all the files. Let's open our canvas game object and let's drag and drop the win panel from prefab for import on it. Let's unpack the prefab completely and let's delete our prefab for import folder. Now let's select our win panel manager and let's drag and drop our winning panel into winning panel variable. Now let's open our winning panel and let's open our parent price. Let's click on it and we can see that this image will represent our type of the price. Now select our win panel manager and let's fill the win type image variable with our image price. And to fill price text variable, let's open parent how much and let's drag and drop text how much into price text variable. And that's everything for this lesson, and we will continue in the next one. In this video, we will be creating button manager and we also finish our winning panel. So let's start. Let's select our managers folder and inside let's create button manager C# script. Let's open it. Let's clean the file. On top, let's create new public class with the name onClick. This class will have public string variable called name, so we can write the name of the button. Then we need a reference to the actual button, so let's write public button and let's import unityengine.ui namespace, and the name will be my button. Now we need a reference to our button click event, so let's create public button click event and let's also add static unityengine.ui.button namespace, and the name will be button click. Then let's create onValidate method, which basically run always when we change some value inside inspector. And here we will be checking if our button doesn't equals to null, and if not, our button click event will be basically my button.onClick event. So what we are doing, we are basically storing the event from UI button game object inside our onClick class. Let's add system.serializable attribute so we can see the values inside editor. And now inside our button manager, let's create public list of type onClick with the name myButtons, which will equals to new list of type onClick. Now let's create onEnable method where we'll be looping over these myButtons, and let's write button.myButton.onClick equals to button.buttonClick. So basically always when we enable our button manager, the UI buttons get button click event from onClick class, which have all the values already filled automatically with onValidate method. Then let's create private void onDisable and let's loop over my buttons. And let's write button.myButton.onClick equals to null. Now the reason why we are assigning null to our UI button onClick event is that we want from our button manager to be centralized. So for example, When we turn off our button manager, all the events from our UI buttons will be cleared, but when we turn it back on, all the events inside UI buttons will be filled automatically again. And this is good for one simple reason. If your game have a lot of buttons, you can manage all of them with one button manager. Now to finish our button manager, let's add execute in edit mode attribute. So our onEnable and onDisable methods will work also inside editor. Now let's save the file and let's go back to editor. So let's select our managers, game object, let's create new one and let's call it button manager. Let's drag and drop our button manager script on it. Let's open my buttons list. Let's change the size to be 1. Let's change the name to be Vim panel. And we can see our element 0 also changed to Vim panel. That's why we use the name variable. Now let's fill the my button variable. So let's open the parent button, open the button, and let's drag and drop image.bg into our my button variable because image.bg have the button component on it. Now for our click events, let's add new event and let's drag and drop our Vim panel manager on it, and let's choose the functions from Vim panel manager and let's choose Vim panel click. Now we can test enabling and disabling of our button manager. So let's select our image.bg button game object and let's click on it, and we can see the onClick event is filled. Now let's go back to our button manager and let's turn it off. And let's click again on our image.bg game object, and we can see the event is clear now. Now let's go back to our button manager and let's turn it on. Let's select our image.bg again, and we can see the onClick event is there. So the centralized button manager is very useful when you have a lot of buttons and you want to test them. Now to finish our winning panel, let's select our database and let's click on a bonus sprite and let's choose Cloverleaf. For money sprite, let's choose money icon. Now let's change the size of money prize list to be 1. Change probability to 1, so our ticket will always win, and let's change price to be 10. Change bonus prize list size also to be 1, probability to be 1, and price to be 3. So also our bonus area will always win and the price will be 3. Now let's select our winning panel and let's turn it off. Now let's open our ticket A, select a ticket section, and we can see the area type is money. Now let's open our ticket section parent bonus and select that ticket section and let's change area type to be bonus. Now we can test it, so press play. And when we scratch our money ticket section, our winning panel appear with a money symbol and 10 as a price. And when we scratch our bonus area, winning panel appear with a bonus symbol and a 3 as a price. So we see everything is working, also our button manager. So thank you, and I'll see you in the next lesson. In this video, we will be creating a system which will be filling our board images with a random sprites, with the rules if the section is winning or not. So let's select our board folder and let's open our ticket script. And first we need to fill how much of winning board images we will have in our section. So inside our prepare ticket for each loop, let's write item.fill winboard image count method. Let's copy the method name and let's implement it inside our ticket section. And here let's write public void fill winboard images count. And for this method we need also a variable. So let's write public int winboard images count with the default value of 0. Let's create a header. Let's call it money part, because we want the settings to be applicable only for money area type. Now let's put our variable inside the method. And to fill it, we need to open our setting database. And here we would like to add a list of ints with the name WinBoardImagesCountDefault. And let's add a header with the name WinBoardImagesCountDefault. Let's go back to ticket section and let's fill it. Again, we can use our random method from utility. So let's write utility random from list. And inside, let's write our setting database dot instance dot our WinBoardImagesCountDefault. So this method is finished. Now let's go back to our ticket. And now let's finally add a method which will fill these board images. So let's write item.fillBoardImages and let's put item.areaType as a parameter. Now again, we need to implement this method. So let's open our ticket section script and let's create new public void fillBoardImages method with the areaType as a parameter. Inside, let's create two if statements. First will be if areaType will equals to areaType.money, and second will be if areaType equals to areaType.bonus. And now, before we can continue, we need to create a new class where we can store a sprite and also the variable if the sprite is winning one. So let's open our board images script, and here let's write public class board image settings. And let's create also system.serializable attribute. And let's create first variable, which will be public sprite mySprite, and second will be public bool isWinning with the default value of false. Then let's create constructor. Let's add underscores to our parameters, fix them inside constructor, and now we can delete these keywords. Now let's go back to ticket section and let's continue inside areaType money. And now we will put our new class into the list. So let's write list of board image settings with the name board image settings list equals to, and now we need to create new method which will create for us this list. So let's write make board images array, and there will be three parameters. First will be WinBoardImageCount, so we know maximum number of winning sprites. Second parameter will be BoardImageList.count, so we know how many board images we have in the section. And the last will be WinSettings.didIwon. So if the section should be a winning one, we will calculate the proper number of winning sprites. Now we can generate this method. Let's change the access modifier to be public static. Let's delete the exception. Now we need to store a copy of a list which represents all symbols we can use inside our board images. So let's write list of sprites, all sprites copy equals to, and let's define all the symbols list inside our settings database. So let's open it and let's create this list. So let's write public list of sprites with the name all board sprites. Let's create a header and the name will be all board sprites. Let's go back to our ticket section and our all sprites copy list will equals to settings database dot instance dot all board sprites. And to create actual copy, not the reference of the list, let's add toList at the end. Then we need to define the sprite called local winning sprite, and for our winning sprite we would like to choose one random sprite from our all sprites copy list, but we also want to remove the sprite from the list. So because of that, we need to create a new method. So let's open our utility script. And we want to create again a generic method. So let's write public static t random from list remove of a type t, and the parameter will be list of type t called the generic list. Now let's define int random index equals to random dot range between 0 and generic list.count, and then our random member of type t will be our generic list, and let's put our random index inside the member. And now to remove our random member from the list, let's write generic list.remove at, and let's put random index inside the parameter. And the last step will be to return our random member. So let's go back to ticket section and let's continue. So our local winning sprite will equals to utility.random from list remove, and let's put all sprites copy into the parameter. Now let's ask if did I won equals to true. So basically if we have winning ticket, let's create for loop from I equals to 0 to I is less than to winning board images count. Now we need to define the list which we will be returning with this method. So let's write list of board image settings with the name board image settings list equals to new list of board image settings. And inside for loop, let's add to this list new board image settings. So we will be using the constructor, and the first parameter will be our local winning sprite, and the second parameter will be the true. And it makes sense because we want to loop over all winning images, and they will showing the same local winning sprite. Now let's make a case when our section is not the winning one. So let's create else statement, and let's create for each loop again. But now our loop variable I will start from 0, and it will end when our I will be less than winboard image count minus 1. That means if our section is not winning one, our winning sprite count will always be less than the desired number of winning sprites. And to our board image list, let's add new board image settings with a local sprite and a true as a second parameter, because the sprite is still winning even though the ticket is not. Now for the rest of our sprites, let's write for each loops which will be looping through all sprites copy, and inside let's create for loop from I equals 0 to I equals to winboard image count minus 1. And for this, let's create new list variable of a type sprite with the name non-winning sprites, which will equals to new list of sprites. And let's use it inside our for loop. And let's add to this list only the item, which is basically non-winning sprite. And as you can see, we are doing this non-winning sprite list in a way where we can have multiple numbers of the same symbols, but still the number of the same symbols will always be less than our desired winning symbol count. Now let's ask if non-winning sprite .count doesn't equals to 0, and that means our newly created array is not empty. So we can create a for loop where our loop starts from already partially filled board image settings list.count, and it will end when I is less than count. Now let's rename the count variable, which we are using also as a parameter for the method, to current board images count, so we know better what it means. And let's finish our board image settings list where we add to it new board image settings. And for the first parameter, and we want to choose random sprite from our non-winning sprite list. And when we choose one, we also want to remove it from this list. So for our first parameter, let's use utility.random from list remove, and our list will be non-winning sprites. And for second parameter, let's use false, because these sprites are not winning. And now if our non-winning sprites count equals to 0, let's create else statement, and let's copy and paste the same for each loop. But now instead of non-winning sprite list, let's take and remove random sprite from all sprites copy. Now our board image settings list is almost final, but we want to shuffle it so it will appear much more randomized. So let's write board image setting list equals to, and now switch to our utility script, and we want to create another generic method which will shuffle the list. So let's create public static method with a return type of list of the type T called shuffle list, of type T, and the parameter will be list of type T with the name generic list. Now we can create shuffled list easily by representing each member of the list as a random number, and then we will order this list by this number. So let's write list of T sorted equals to generic list dot order by, we need to add link namespace so we can use the order by method. And to represent each member as a random number, let's create a lambda expression and let's write a lambda operator random.range between 0 and 100. And to finish it, just write toList at the end. And now we can return our sorted list, which is basically our shuffled list. Now we can go back to our ticket section and our board image settings list equals to utility.shuffle list, and let's put our board image settings list as parameter. Now for easier access to our winning sprite symbol, let's add it at the last position to our list. So let's write board image settings list dot add, and let's put new board image settings, and inside let's put local winning sprite as a first parameter and true as a second. And as a final step, let's return our board image settings list. So now our make board images array method is finished, and we will continue in the next lesson. So thank you, and I'll see you there. In this lesson, we will continue exactly when we finish in our last lesson. So let's go back to our field board images method. Now we need to create a new method which will connect our board images settings list with our UI board images. So let's write connect board settings, and let's put our board image settings list as a first parameter, our board image list as a second parameter. Next parameter will be win board images count, and the last parameter will be our winning sprite. But first we need to define winning sprite as a variable. So let's write private sprite winning sprite variable, and inside our connect board settings we need to pass it by reference. So let's write the ref and the winning sprite. And why we need to pass it by reference? Because we don't want to change a property of the sprite like a texture. We want to change the reference of the winning sprite itself. Now let's generate this method. Let's clean the exception, and let's write for loop, and we will be looping from 0 to I less than board images list.count. And inside our for loop, we would like to connect our board images with our board image settings, and let's do it with a new initialize method. So let's write board image list I member dot initialize, and let's put board image settings list I member as a parameter. To create initialize method, let's open our board image, and let's write public void initialize, and let's put board image settings as a parameter. Now we need to create UI image variable which will be representing our board image symbol sprite. So let's write public image, and let's import Unity Engine.UI namespace, and the name will be board image. And inside initialize, let's write board image.sprite equals to settings.mysprite. Now we want to store the option if our board image is the winning one. So let's do it with a new winning method, and let's put settings.isWinning as a parameter. Now create this method, change it to be public. Now to store if our board image is the winning one, let's create new public bool isWinning variable with a default value of false. And inside our winning method, let's write isWinning equals to isWinning. Now let's change the parameter name with underscore, and let's change it inside the method. And now our new methods are finished. So let's go back to our ticket section. And now our for loop with initialize method is working. And what we are missing is to change our winning sprite. So let's write winning sprite equals to, and we know we put winning sprite into the last member of our board image settings list. So let's write board image setting list dot last and dot my sprite. Now let's go back to fill board images and let's finish our bonus part. And we know our bonus part have always two board images where one of them is price text, but we don't want to fill them with the sprites, we just want to fill winning settings. So let's fill first one. So let's write board images list 0.winning and let's put win settings.did I won as a parameter. Now for the second board image, let's copy the line and let's change the member value to be 1. Now we mentioned that our second board image inside a bonus part is a text, so let's create it as a variable. Let's write public text mesh pro UGUI, but first let's add tm pro namespace, and the name will be bonus text, and we will be only filling it if our area type will be bonus. So let's create header and let's rename it to bonus part. Now let's go back to editor. Let's select our database, and here we want to fill our board image sprites. So let's select our sprite folder, select our object 01 to object 09, and let's drag and drop them to the all board sprites. Then let's open WinBoard image count default, and let's change size to be 1, and let's write 3 for the member. And that means we will be looking for the 3 same symbols to win the prize. Now let's open our canvas and let's open our board image prefab. Select our board image and we want to fill our board image variable. So let's drag and drop image main and let's put it to our board image variable. Let's go back. Open the ticket section parent bonus, and here what we need to do is select the ticket section and we would like to fill the bonus text. So inside board piece text, let's open board image and let's drag and drop our text game object into bonus text variable. Now we can close it and we can test it. So press play. And we can see in our scene view that our board images are generated properly. And when we turn on the debug mode, we can see that our winning sprite is object 05, which is the chip sprite, and we can see we have 3 of them. So let's try to scratch it. And when we finish it, our winning panel will appear. Now let's scratch the bonus part, and we can see that our ticket is also winning. Now let's turn off the debug log. Let's change probability for money prize list to be 0 and bonus prize list to be 0 as well. So our ticket should not win money and bonus prize. So let's try it. Let's select our ticket section. Let's turn the debug mode and we can see our winning sprite is object 03. So let's click on it and it looks like a token picture, and we can see in our scene view we have only 2 of them. Now let's scratch our ticket. And when we finish, we can see our ticket is not the winning one for both money and bonus sections. So this is working perfectly. Now let's select our database. Let's turn off the debug mode and let's change probabilities to be 1 for money and for the bonus. So for the testing, our ticket will always win. And that's everything for this lesson. So thank you, and I'll see you in the next one. In this lesson, we will change our winning condition. So our section will be finished not only when we scratch all the board images, but we can finish it just by scratching the winning sprites. So if we find our winning sprites and our ticket is not scratched entirely, it will still finish. So let's open our ticket section script. And here we would like to define when our ticket is finished. So under update all count, let's add board image, my board image parameter, and let's ask if my board image dot is winning equals to true. Let's call update winning count method, which we don't have yet, so we need to generate the method. Let's delete the exception, and for this method we need to define a variable. So let's write public int finished winning sprites equals to 0. And inside our method, let's increase the value by 1 with a plus. And let's ask if finished winning sprites equals to win board images count. And then we know we scratched all our winning sprites and we can finish our section. Let's go back to board image. And here let's add parameter to update all count method. So let's put this here, save the file, and let's go back to editor. Let's press play. In a scene view, we can see the 3 dices are the winning sprites. So let's try to scratch them first. And after we did, the ticket will finish with the winning panel. So that's exactly what we wanted. And our bonus part worked as before. So let's turn off the play mode. Next thing what we want is to show our winning game object when we scratch the winning sprite. So let's open ticket section script again. Go to wait until scratching finish method. And here let's add new method with the name show winning. And we need to generate it. Let's delete the exception. And inside let's create for each loop where we will be looping over our board image list. And for each of the board image, we will be starting coroutine. And let's put item.check if finished and show winning as a parameter. And we need to define it inside our board image. So let's copy the name, go to our board image. Here let's create public IEnumerator, check if finished and show winning. Now we need to wait until our board image is scratched. So let's create a while loop where we are looping when is finished will equals to false. And if is false, let's yield return null. And when the board image is finished, let's ask if is winning equals to true. And if yes, we need to first create a reference to our winning game object. So let's write public game object winning game object. Now let's continue inside our coroutine where we turn this game object on with a set active to be true. Now when we start our game, we want this game object to be turned off. So inside awake method, let's write winning game object dot set active to be false. Now let's save the file and let's go back to editor. Let's open our ticket section and let's open our board image prefab. Select the board image. Now we need to fill this winning game object, and we have prepared the winning mask under our text game object. So let's drag and drop our winning image scale up into our winning game object variable. Now let's exit the prefab. Now we can test it, so let's press play. Now we can see our winning game objects are these 3 cards. So let's scratch them, and the moment when we touch them, our mask will appear and we have visual representation of a winning sprite. Let's do the same over our bonus part and we also see the mask appear. Now we can turn off the play mode. Let's select our database and let's change probability for money and bonus to be 0. Let's test it again. And let's start scratching. And the mask also appear for our winning sprites, even if our section is not winning. And that's exactly what we wanted. And we also finish our lesson. So thank you, and I'll see you in the next one. In this lesson, we will be creating a game manager, and inside we will be creating a game loop. So when we finish one ticket, next ticket will appear, and this will go over and over. So let's select our managers folders and let's create new script. Let's call it Game Manager. Let's open it, clean the file. First, we need to store a reference to our ticket. So let's write public ticket current ticket. And our main loop will be a coroutine. So let's write public IEnumerator update ticket settings. And inside, first, we need to prepare our ticket. So let's call current ticket.prepare ticket. And this method already exists inside our ticket script, so we don't need to create new one. And then we can also call the coroutine, which is also inside our ticket script. So let's write yield return current ticket.process one by one section. And when the process ends, we know the ticket is finished. We can start again this whole method. So let's write start coroutine and let's put update ticket settings inside the parameter. And now we have basic game loop where when we finish our ticket, we will getting new one. Now when we start our game, we need also to start our coroutine for the first time. So let's create start method and let's write start coroutine and let's put update ticket settings into the parameter. Now let's go to our ticket script. And here we need to modify our prepare ticket method because we need to reset some values when we call this method over and over. So let's call new reset ticket method first. And we don't have it yet, so let's generate it. Let's delete the exception. And let's create for each loop. And we will be looping all of our ticket areas. And inside, let's reset each of our ticket area with item.reset section. And let's put item as a parameter. Now let's copy the name and let's open our ticket section. And let's create this method. So let's write public void reset section and let's put ticket section as parameter. And what we want to reset is finish board image count, which will equals to 0. Then we want finished winning sprites to be 0. Next, section finished to be false. Next, we also want to reset our scratching area. So let's write my scratch area dot reset scratch area. And also we would like to reset our board image list. So let's create for each loop where we are looping our board image list. And let's write board image dot reset board image. Now let's go to our scratching area and let's create the method. So let's write public void reset scratch area. And here first we would like to reset our game object to be active. So we want to first show the scratching area. Then we would like to reset our scratching enabled to be false. Now let's go back to our ticket section. Let's fix the reset board image method. And let's go to our board image and let's create this method. So let's write public void reset board image. And first what we want to do is to turn off our winning game object. So let's write winning game object dot set active to be false. Then we want to reset our visited samples to be 0. Is finished to be false. Then our current progress to be 0. And also we would like to reset our samples. So let's loop over all samples. And let's write sample.reset sample. Let's copy the method name. Let's open the sample script and let's create the method. So let's write public void reset sample method. And here we would like to reset the color. So first let's write color yellow equals color.yellow. Then let's change the alpha of this yellow color to be 0.2. And now let's assign our color to the myImage variable. So let's write myImage.color equals yellow. Save the script, go back to ticket. Here we have the start method, which we don't need anymore because our game manager is doing all these steps. So let's delete it. Save the file. Let's go back to editor. Open the managers. Create new game object. Let's name it Game Manager. And let's drag and drop our Game Manager component on it. Now let's fill the variable. So open the canvas and let's drag and drop ticket A game object into current ticket variable. Now let's press play and let's first scratch our money part. After that, let's scratch our bonus part and we see we instantly get new ticket which we can scratch again and again. So our game loop works how we wanted. Let's exit the play mode. Let's go back to the database game object. Let's change the probability to be 1 to both money and bonus and let's check it again. And we can see now we are showing also winning panel, but everything works how it should. And that's basically everything for this lesson. So thank you, and I'll see you in the next one. In this video, we will be creating a scoreboard UI element. So first, let's import a package. Click on our scoreboard. Let's import all of the images. Now let's open our canvas. And let's drag and drop our scoreboard there. Now let's unpack the prefab completely. And let's delete prefab for import folder. Let's select our ticket A and change the anchors a little bit so our scoreboard will fit better. We will be changing these final positions later when we will building our game, but for now let's do it roughly like this. Now let's check our scoreboard. Let's open it. And we have add-on panel where we will be writing what to do and how much we can win. Then we have main panel where we will be storing our score. Then we have winning sprite panel where we will be showing which sprite we need to find to win. And the last we have number panel where we are showing how much of these sprites we need to find to win the prize. Now to integrate it in our game, let's select our managers and let's create new C# script. And let's call it scoreboard manager. Let's open it, clean the file. Let's create a static variable of our scoreboard manager with the name instance, and inside await method we ask if our instance doesn't equal null, and if yes, our instance will be this component. Now we need a couple of variables. So first let's write public TextMeshPro UGUI, but let's add TMPro namespace and the name will be money score text. Next we want public TextMeshPro UGUI bonus score text. Next we need public TextMeshPro UGUI left text, then public TextMeshPro UGUI right text, then public TextMeshPro UGUI number text. Then we need also game object, so let's write public game object number panel. And the last we need public image. Let's add our Unity Engine.ui namespace and the name will be center image. Now we have all the variables to connect our UI scoreboard panel. So let's create also some methods. So let's write public void connect money part UI, and in the parameters there will be int winning sprite count, win settings, with the name WinSettings, and sprite with the name WinSprite. And we will be calling this method when our ticket will be showing some money area type section. And inside, let's first activate the number panel with the set active to be true, so we can see how many sprites we need to find. Then for the left text, let's write string left text equals to match with a space at the end. Then let's write string right text, which will equals to win with a space plus our win settings dot price preset dot price dot toString, so we can see our price, what we can win. And for the number, let's write string number equals to winning sprite count dot toString. Then we need another method which will fill add-on UI, and we will put our left text, win sprite, right text, and a number as the parameters. Now let's generate this method, and this method will finally connect our variables with our scoreboard UI elements. So let's write left text dot text equals to left text, then right text dot text equals to right text, then our number text dot text equals to number, and finally our center image dot sprite equals to win sprite. Then we need a second method which will be connecting our bonus part. So let's write public void connect bonus part UI, and let's put TextMesh Pro UGUI bonus board text as a first parameter and win settings as a second parameter. Now, because this will be connected with our bonus section, we don't need our number panel to be active. So let's write number panel.set active to be false. Then let's define our left text. So let's write string left text equals to try. And for the right text, let's write string right text equals to bonus. Now for the center image panel, because we will be inside a bonus section, we would like to show a cloverleaf sprite, and we can import it easily from our database. So let's write sprite WinSprite equals to setting database.instance.bonus sprite. Now we can use the same method fill add-on UI, so let's copy it and paste it. And instead of number, let's use empty string because we don't have number panel when we are showing bonus section. And to finish our method, let's ask if winning settings did I1 equals to true, and if yes, our bonus board text dot text will equals to win settings dot price preset dot price dot toString. And if not, let's create else branch and let's write bonus board text dot text equals to no luck. Now we need another method which will be updating money and the bonus score text. So let's write public void update money and score with the int money and int bonus as parameters. And let's write money score text.text equals money.toString and bonus score text.text equals to bonus.toString. Now let's save the file and let's go back to editor. Now let's open our managers and let's create a new game object and let's call it scoreboard manager. Let's drag and drop our component on it and let's fill the variables. First, let's open main panel and let's grab text money count and let's put it to our money score text. Then let's grab text bonus count and let's put that one to bonus score text. Then let's open our add-on panel and let's drag and drop text left to our left text variable. Now when we select left text, we can see which one it is. Let's select again our scoreboard manager and let's drag and drop text right to our right text variable. And then let's open panel number. And then let's grab text number and let's put it to number text variable. Now for our number panel game object, let's grab panel number and let's put it to number panel variable. And for the center image, let's open our winning sprite panel and let's drag and drop winning sprite to our center image variable. Now our manager is finished and we need to implement it to our game. So let's open board folder and let's open ticket section script. And here let's create a new public void method connect to UI add-on and let's put area type as a parameter. And inside let's ask if area type equals to area type dot money, and if yes, let's call our scoreboard manager dot instance and let's call our connect money part UI. Now let's fill the parameters. First will be win board image count, second we need win settings, and third we need our winning sprite. Now let's create if area type equals to bonus and let's change the method we want to call to connect bonus part UI, and we want only two parameters, and first will be bonus text, which is the text inside actual bonus section, and the second parameter will be win settings. Save the file. Let's go to our ticket script, and here inside prepare ticket in the for each loop we need to add if statement where we are asking if ticket areas.first equals to item, and if yes, let's call item.connect to UI add-on and let's put item.area type as a parameter. And what we are doing is basically we are asking if our current item in the loop is the first section, because if our ticket have more sections, we only want to connect our first section to the scoreboard panel. The next section will be connected later when the first one will be scratched. Now to connect the other sections to our scoreboard UI after the first one will be finished, let's copy the line and let's paste it inside process 1x1 coroutine. And let's change our if statement to not equals the first ticket area. And now we can save the file and let's go back to editor. Now let's press play to test it. And we can see our scoreboard panel is showing that we need to match 3 sprites with a symbol of cloverleaf and we can win 10 points. So let's scratch the ticket. And we found them, so winning panel appeared. Now we see we have a small error. Our scoreboard UI is on top of our winning panel, so let's fix it. Let's select our scoreboard. And first, let's move it under our ticket. Now let's select our winning panel. Let's try to turn it on, and we can see we no longer see the scoreboard. So let's turn it off again. Let's press play. Now we need to find 3 chips, so let's do it. And we can see our winning panel is fixed. Now we can see scoreboard for the bonus section, and that works also nice. But we have one thing which is not working, and that is the actual score for money and for the bonus, which is not updating when we claim the prize. But we will fix it in the next lesson, so see you there. In this lesson, we will fix our scoreboard by creating new manager, which will be storing and loading our progress when we win some prizes, so our scoreboard can show it properly. So let's select our managers folder, let's create a new C# script, and let's call it save load manager. Let's open the file. Let's clean it. First, we need a static reference to our class. So let's write public static save load manager instance. And let's create a awake method where we are asking if instance equals to null. And if yes, our instance will be this component. Now let's create a variable called public int money score. and public int bonus score. And we need to somehow save these variables. And for saving them, we need to create public void save data to player prefs method. And inside, let's write player prefs dot set int, and let's define our string for money score, and it will be save the money, and the value will be our money score. Let's do the same for the bonus. So let's change our string to save the bonus and change the value to be bonus score. Now to load the data, let's create public void load data from player prefs method. And inside first we need to check if the value is already stored. So let's ask if player prefs.hasKey, and the key will be the saved money string. And if we found this key inside player prefs, we can put it to our money score value. So let's write money score equals to player prefs.getInt with the saved money string as a parameter. Now let's copy entire line and paste it. And we need to change it to our bonus. Change the saved bonus string and bonus score values. And we finish the main methods for saving and loading our score. Now we need one more method which will increase the values of our score when we win some prize. So let's write public void increase values, and let's put area type as the first parameter and int value as the second. And inside let's ask if type will equals to area type.money. Let's write money scored plus equals to value. Let's do the same for the bonus. Change the area type to be bonus and the score to be bonus score. Now we know that in the future we will be animating values from the old score to the new score. So we need to create new variables. So let's write public int money old score and public int bonus old score. And let's put them into our increase values method. So money old score will equals to money score and bonus old score will equals to bonus score. So we are also storing the old values before we are incrementing them. Now to save and load our values, let's go to our game manager script. And here first, when we start our game, we want to load our data. So let's write save load manager .instance .load data from player prefs. Then we want to show them on our scoreboard panel. So let's write scoreboard manager.instance .update money and score, and inside our money parameter let's write save load manager.instance .money score, and for bonus parameter let's write save load manager.instance .bonus score. So now when we start our game, these values will be filled automatically and we can see the last progress of our scores. Now let's save the file. Let's go to our winning panel manager. First, inside show winning panel, when we win something, we want to increment the value. So let's write save load manager.instance .increase values. And for first parameter, let's use win settings.type. And for second, let's use win settings.price preset.price. Now we need to save this increased value back to the player prefs. So let's write saved load manager.instance.save data to player prefs. And the last step, we need to update our scoreboard. So at the end of our if statement, let's write scoreboard manager.instance.update money and score. And for parameters, let's use the values from our save load manager. So for the money, let's write save load manager.instance.money score. And for the bonus, let's write save load manager.instance.bonus score. Now let's create some waiting time before we can see the winning panel. So at the beginning of our coroutine, let's write yield return new, wait for seconds, and let's put 1 as a parameter. Now let's save the file and let's go back to editor. Let's select our managers. Let's create new empty game object and let's rename it to save load manager. Now let's drag and drop our save load manager to it and let's press play. And now we can see our score is 0 and 0 for money and bonus. So let's scratch. And when we press claim, our score for money is increased. Now let's scratch the bonus, press claim, and we can see the bonus score increased as well. Let's do it again. And we can see everything is working. So let's turn off the play mode. And now let's see if our values was stored correctly. So let's press play again. And we can see we have the same score as we left the game, so everything works. Let's scratch it for the last time. And we can see our scoreboard panel is working, and that's also everything for this lesson. So thank you, and I'll see you in the next one. In this lesson, we will be creating new ticket type, which can group multiple ticket sections, and whole group will represent one winning area. So let's open our canvas, select our ticket A, and let's duplicate it. Let's move it under the ticket A, and let's change the name to ticket B. Now let's select our ticket A and let's disable it. Open our ticket B and delete the bonus part, so we have only the money part. Now let's open the ticket section parent, open the ticket section, open the board elements and also the vertical, and select two horizontal groups and let's delete them. Open the remaining horizontal group and let's select the last board piece and let's duplicate it. So we have 4 of them. Now select our ticket section and let's change aspect ratio to be 3.2. So we have nice rectangular shape of our section. Now let's select our ticket section parent and let's duplicate it 3 more times. So now we have 4 money sections, but we want to group them to represent one big ticket section. But before we do it, let's open our managers and let's select our game manager and let's drag and drop our ticket B into the current ticket variable. Now to see how it is working right now, let's press play. And we can see each ticket section represent one winning area, but we don't want this behavior. We want to group them. So all 4 ticket sections will represent one winning area. So let's select our scripts folder. Let's go to board folder and let's create new C# script and let's call it ticket section group. And let's open it. Clean the file. Let's move the ticket script up to be near. Now inside ticket, let's create new variable. So let's write public ticket section group with the name section group. And we will be assigning this variable if our ticket areas will represent one group. And let's create also header. And inside header, let's write optional section group. Inside prepare ticket, we need to check if our section group was assigned. So let's ask if section group is equal to null. And if yes, let's put our old for each loop inside this branch. And we are treating each ticket area as a separate winning part. Now, if our section group was assigned, let's create else statement. And here we need to define the same methods which we are defining for our separate ticket areas. So we need to define section group dot fill winboard image count. Then we need to define section group dot fill win settings. Then we need section group dot fill board images, and we need this ticket as a parameter. And the last we need section group dot connect to UI add-on. Now let's select our first method, let's copy it, and let's go back to our ticket section group. And here let's write public void fill win board images count. And for this method, we need to create public int win board image count variable which equals to 0. Let's put it to our method. And we can check how we was calculating it inside our ticket section. So let's grab the ticket section and let's move it near to our script. And let's find fill win board images count method. And let's copy the value. Go back to ticket section group and let's paste it. And we need to change win board image count default variable. So let's select our setting database. Let's move it near to our scripts. And here, let's create new public list of int with the name win count 1x1 ticket. Here we will be defining how many sprites we want for a whole ticket if we have multiple sections. And let's also copy the header and let's change the name to win 1x1 ticket count. Let's save the database. Go back to ticket section group and let's change the name to be win count 1x1 ticket. Now we need to fill win settings. So let's write public void fill win settings. And for this method, we need also define a variable. So let's write public win settings, win settings. Let's paste it to our method. And let's check what we was doing in our ticket section. So let's copy the money part of the method and let's paste it into our win settings. Let's check next method. Let's copy it and let's create public void fill board images and let's put ticket with the name ticket as a parameter. Now we need to access to all of our board images. So let's write list of board image with the name all board images equals to, and because we have multiple ticket sections and each ticket section have a list of board images, we need to write ticket.ticketareas.select many, and select many basically creates one list from a multiple lists of board images. But we need to add system.link namespace to use it. Now inside the parameter, we need to create another lambda expression which reference all these board images lists. So let's write a lambda operator a dot board image list, and at the end we need to finish it with a toList method. And then we need to create a list of board image settings and let's call it board image settings list and will equals to, and let's check again our ticket section. And we want to use make board images array method. So let's copy the name. Let's go back to ticket section group. And because the method is static, we can just write ticket section dot make board images array. And let's put our win board images count as the first parameter, all board images dot count as a second, and win settings dot did I1 as a third. Now let's go back to our ticket section. And we need to use connect board settings method as well, but we need to fix the access modifier to be public and static. And now we can see we made a small error. Instead of lowercase winning sprite parameter, we was using uppercase winning sprite global variable. So let's fix it. Let's go back to our ticket section group and let's continue. Let's write ticket section dot connect board settings and let's put board image settings list as the first parameter, all board images as a second, win board images count as a third, and for the last we need to create public sprite winning sprite variable and let's add it to our parameter. but we want to pass it as a reference, so we need to use the ref keyword. Now let's save the file and let's go back to ticket. Let's copy the last method, go back to our ticket section group again, and let's write public void connect to UI add-on, and let's copy the method from our ticket section. So let's select the money part and let's copy it. And inside our ticket section, let's paste it as it is. And we finish all the methods from our ticket script. So now let's select our game manager script and let's move it nearby. And now we need to change our process one by one section method because we need to add one option for our ticket section group. So let's create new method with the name process ticket. So let's go back to our ticket script, and here let's create it. So let's write public IEnumerator process ticket, and inside let's write if section group equals to null, we will call the old coroutine. So let's write yield return process one by one section. Now if our section group is assigned, let's create else statement and let's write yield return section group dot process one by one ticket, and let's put this ticket as a parameter. Now let's copy the name of the method and let's go to our ticket section group and let's create public IEnumerator process one by one ticket, and let's put ticket with the name ticket as parameter. Now inside our method, we want to start new coroutine with the name wait until ticket finish, and let's put ticket as a parameter. Now we need to define this coroutine, so let's write public IEnumerator wait until ticket finish, and let's put ticket with the name ticket as parameter. And here what we want to do, we want to check if the whole ticket was finished. So let's create while loop, and inside we will be asking if ticket finished equals to false, and if yes, let's yield return null. Now we need to define this ticket finish variable, so let's write public bool ticket finished equals to false. Now when our ticket is already finished, we want to be sure that all the ticket sections are finished as well. So let's create for each loop where we are looping our ticket.ticket areas, and we want to finish each section. So let's write item.section finished equals to true. Now let's go back to our process one by one ticket, and here we want from our sections to be enabled one by one. So let's create for each loop, and again let's loop over ticket.ticket areas, and we want to start coroutine one by one for each ticket section. So let's write yield return item.wait until scratching finish, and after our ticket area is finished, we need to ask if our ticket is already finished as well, and if not, we can continue normally with finishing our scratching area. So let's write item.myscratcharea.finish processing. Now, when all ticket areas are scratched, we can run the final coroutine. So let's write yield return ticket.finish processing, and let's put ticket.ticket areas as a first parameter and win settings as a second. Now we can see we have one error inside finish processing method. So let's open our ticket script so we can fix it. And here we need to fix our first parameter. So instead of taking one ticket section, we need to take a list of ticket section with the name section list. Now we need to fix these errors. So let's create for each loop, and we will be looping through section list. And let's basically cut and paste the section myscratcharea finish processing there and change the name to item. Next, we need to fix error inside process one by one section method. Instead of calling an item, let's call a new list of type ticket section, and let's fill the list with the item. Let's save the file. Now to continue, let's go back to our ticket section, And here we want to add some methods by which we can calculate if our ticket was finished or not. So first let's create reference to our ticket section group. So let's create public ticket section group with the name section group. And let's also add a header with the name optional section group. Now let's scroll down to our wait until scratching finish method. Now at the end of the method, when our ticket section is already finished, we want to ask if our section group was assigned. So let's ask if section group doesn't equal to null, and if it's true, let's also call new method section group.finish ticket area, and that's the one place from where we are giving feedback to our section group. The second place is inside update winning count method. So we won't have possibility to finish our section group when all winning sprites are finished. So let's ask if section group doesn't equals to null, and if it's true, let's call new method with section group dot update winning count. Now we need to define these two methods inside our ticket section group. So let's open it. First, let's create public void update winning count. And for this method, we need to create new variable. So let's write public int finished winning board images equals to 0. And let's put it to our update winning count method. And let's increment them. So always when we scratch some winning sprite, our update winning count method will increment the finished winning board images variable. And then we can ask if our finished winning board images variable will equals to win board images count. That means if it equals to all winning board images, and if yes, let's change our ticket finished variable to be true. Now let's implement the second method. So let's write public void finish ticket area. And for this method, we also need to create new variable. So let's write public int finished ticket areas with a default value of 0. And inside our method, let's increment it by 1. Then we need to ask if finished ticket areas equals to areas count. That means if we finished all the areas. And if yes, let's change our ticket finished variable to be true. Now the areas count we don't have yet. So we can create public int areas count method with a default value of 0. Now we need also a method which will be resetting all the values when we will be calling new ticket. So let's create public void reset settings method. And let's put ticket as a parameter. Inside, let's fill our areas count method. So let's write areas count equals to ticket.ticketAreas.count. Next, let's reset ticket finished to be false. Next, we want finished winning board images to be 0 and our finished ticket areas to be 0 as well. Now to call these reset settings, let's go back to our ticket script. And first, inside our awake method, let's ask if our section group doesn't equal to null. And if not, we want to assign our section group to our ticket areas. So let's create for each loop and let's loop over ticket areas. And inside, let's write item.sectionGroup equals to section group. Now for resetting our section group, let's go to reset ticket method. And here let's ask if section group doesn't equal to null. And if not, let's call section group dot reset settings and let's put this ticket as parameter. Now let's save the file and let's go back to editor. Let's select our ticket. Now let's add our ticket section group component on it. Let's drag and drop our ticket section group into section group variable. select our database, and we need to fill the win count 1 by 1 ticket. So let's add one element and let's change it to 5. So we need to find 5 same sprites to win the prize. Then let's select again our ticket B and let's press play to finally test it. Let's scroll down to see ticket section group and let's start scratching. And we can see when we are scratching over our winning sprites, the finish winning board images variable is increasing. And when we finish the sections, the finished ticket area variables are also increasing. And when we find the last winning piece, our winning panel will appear. So we can do it again, and we can see everything works how we wanted. And that's the end of this lesson. So thank you, and I'll see you in the next one. In this video, we will be creating different section group type. So instead of scratching sections one by one inside a one section group, we will be scratching them all at once. So to start, let's open a canvas. Let's select our ticket B. Let's duplicate it, move it under our ticket B, and let's rename it to ticket C. Select our ticket B and let's disable it. Now open the ticket C, select our 3 parents and let's delete them. Now let's open our remaining parent. Open the ticket section, open the board elements, open the vertical, the horizontal, and let's select last 3 board pieces and let's delete them. Now select our ticket section and change the aspect ratio filter to be 1. So we have nice square ticket section. Now let's select our ticket C and let's create empty game object and let's change the name to horizontal group. And let's add the horizontal layout group component on it. Check control child size, width and height and change child alignment to be middle center. Now let's drag and drop our ticket section parent under our horizontal group and let's duplicate it. Now let's select our horizontal group and let's duplicate this one 2 more times. Now open the middle one and let's delete the second ticket section parent. And now we have nice 5 sections which we can use for our new ticket section group type. Now let's select our ticket C and let's open our ticket section group script. And here we need to create 2 options if our section group will behave like the old one where we are scratching one by one section, or like this new one where we want to scratch all sections all at once. So let's create public enum with the name scratch by and let's add 2 options. First one will be one by one ticket and second one will be all at once ticket. Now inside ticket section group, let's create public scratch by with the name scratch by variable. Also let's create header and inside let's create a string with the name user settings. And for our values under, let's copy the header and let's change the name to be field by ticket. So inside editor we know which values are set by user and which values are set automatically by ticket script. Now we need to change our methods to reflect these 2 section group types. So first let's scroll down to our fill winboard images count method and let's create if statement where we are asking if scratch by equals to scratch by dot one by one ticket and the old statement is good. Now let's duplicate the line and let's change scratch by dot all advanced ticket. And also let's delete the win count one by one ticket because we need to create different variable inside our settings database. So let's open it. And here let's create new public list of int with the name win count all advanced ticket. And let's copy and paste header and let's name it win all advanced ticket count. Save the settings database. Let's go back to our section group and let's use our new variable. Let's switch to the ticket script. Here we need to add a new option inside process ticket. So let's create if statement where we are asking if section group.scratchby equals to scratchby.oneByOne and if yes, let's call the old coroutine. Now for second option, let's duplicate the line and let's change section group.scratchby equals to scratchby.allAdvancedTicket. Also, we can fix the typo. And let's call a new coroutine with the name process allAdvancedTicket. Now let's copy the name and let's open our ticket section group. And let's create public IEnumerator process allAdvancedTicket, and let's put ticket with the name ticket as parameter. Now inside our method, what we want to use the same start coroutine method as we was using in the old process OneByOne. So let's copy and paste it. Now we can also reuse our last line. So let's duplicate also that one. But for the middle part, we need to do something different because we want to run all the scratching of our areas at once. We need to start our wait until scratching finish coroutine also all at once. So we need to create new coroutine which can start multiple coroutines, but it will end only when all of these coroutines are finished. So let's write yield return utility.run coroutines all at once wait to finish, and our first parameter will be this mono behavior, and we need to use one because our utility class is standard class. It is not a mono behavior. So when we want to call start coroutine, we need to use one. And for the second parameter, we need to provide a list of our coroutines. And the easiest way to provide this list is to use a lambda expression. So let's write ticket.ticketAreas.select, and inside let's put a lambda operator a.wait until scratching finish, and at the end let's just write toList. Now let's copy the name of the method. Let's select our utility script and let's move it nearby. And inside let's write public static IEnumerator, and let's paste our run coroutines all at once wait to finish method. And our first parameter will be mono behavior mono game object. Second parameter will be list of IEnumerator with the name myCoroList, and the last parameter will be float wait in between with the default value of 0. Now inside the method, let's first create new list of coroutines. So new list of IEnumerator with the name new routine list, which will equals to new list of IEnumerator. And this list will be very helpful to check if our coroutines are finished. Now create for each loop where will be a looping over our myCoroList, and inside we want to use our monogame object to start the coroutines, and it will be starting new one with the name check if running, and we will be using item coroutine as a first parameter and our new routine list as a second. Now we need to generate this method. Let's change the string return type to IEnumerator, and let's rename the item parameter as a routine. And this will be simple method which will be just adding our coroutine to our list, and when our routine will finish, it will remove it from it. So we will have an indicator if our list is not empty, we have still some coroutine which is running. So let's continue, let's delete the exception. First, let's add our routine to the list. So let's write new routine list dot add, and let's put routine to the parameter. Now let's run it. So we can write yield return routine, and when it finish, we can remove it from the list. So let's write new routine list dot remove, and let's put routine as a parameter. Now let's go back to our method above, And first, let's implement our wait in between parameter. So inside our for each loop, let's ask if wait in between doesn't equal to 0. And if not, we want to wait some seconds. So let's write yield return new wait for seconds, and let's put wait in between as parameter. And now finally let's create the while loop where we will be asking if our list is empty. That means if all of the coroutines was finished. So let's write while new routine list dot count doesn't equals to 0. We would like to yield return null. Basically, in other words, we are waiting until the list will be finished. Now we see we have some errors, so let's delete the system namespace if you have it. Now save the file and let's go back to our ticket section group, and we see everything is finished. We don't have any errors. So let's go back to editor. Now let's select our database game object. Now let's add two elements into win count all advanced ticket variable, and let's change first to 1 and second to 2. So we need to find 1 or 2 same sprites as our winning sprites to win the prize. Now let's select our ticket C, and let's change scratch by variable to be all advanced ticket. And we can also check our ticket B, and it have default value 1 by 1 ticket. Now let's open our managers. Let's select our game manager, and let's drag and drop our ticket C into current ticket variable. Now let's select our ticket C again. Let's scroll to our ticket section group, and let's press play. Now we can see we need to find one card. So let's start scratching, and we can see we can nicely scratch over all ticket areas without any waiting. So this is exactly what we wanted. Let's do it a couple more times. And we can see everything works how we wanted. And that's all for this lesson. So thank you, and I'll see you in the next one. In this lesson, we will be creating an option to hide the sprite symbol from our panel. So instead of showing a concrete symbol, we will show the question mark. So basically, we know how many same sprites we need to find, but we don't know the symbol. So for this, inside the scripts folder, select our board folder, and let's open ticket section script. And here, let's create new public bool show any sprite variable with the default value of false. Now we need to integrate this variable into our methods. So first, let's scroll to our connect board settings method, and let's add to our parameter bool show any sprite. And at the end of the method, let's ask if show any sprite equals to true. And also we need to add if winboard image count doesn't equal 1. That means we can't match one sprite of any symbol because it doesn't make sense. Then we need to put question mark to our winning sprite symbol. So let's write winning sprite equals 2. Now let's open our setting database, and let's add public sprite with the name AnySprite, and let's add also header with the name AnySprite. Let's save the file, go back to our ticket section, and basically our winning sprite equals to setting database.instance.AnySprite. Now let's create else statement, and here we will be using our old winning sprite assignment. Now let's fix our connect board settings method inside fill board images. So let's add our show any sprite there. Now we also want to change the connect money part UI to have show any sprite as a parameter. So let's add it here. And also we need to change our method inside scoreboard manager. So let's open that one. And let's add bool show any sprite parameter. And inside the method, we need to ask again if show any sprite equals to true and winning sprite count doesn't equal to 1. Let's change our left text to equal any with a space. Save the file, and let's go back to ticket section script. So this is fixed. Now let's scroll down to wait until scratching finish method, and let's add here bool show any sprite as a parameter. And here we would like to only call our show winning method if our show any sprite equals to false. So basically we don't want to see any winning game object because we don't know which sprite symbols we are looking for. Now let's fix this method inside our ticket script. Let's scroll down to our process one by one section, and let's add item.showAnySprite as a parameter. Now let's switch to ticket section group. We need to fix all errors, but first let's define public bool showAnySprite variable with a default value of false, and let's add it to our methods. Let's save the file. Now let's go back to editor. Now let's click on database and let's assign the sprite to our AnySprite variable, and let's choose the question mark symbol. Let's go back to ticket C and let's turn on the show AnySprite for testing. Let's press play. And now instead of knowing the winning sprite, we see the question mark. But for testing, when we check our left scene view, we can see the two same symbols are the dices. But now watch, when we scratch first one, we don't see any winning sprite game object, which is good. But even when we scratched the second one, we don't see any winning sprite mask. So we need to fix it. Let's go back to our ticket script. And inside finish processing, let's also add bool show any sprite parameter, and let's ask if show any sprite equals to true, and inside let's ask if winning settings dot did I won equals to true. So basically if our ticket is the winning one, let's create for each loop where we are looping our section list, and for each section we will call show winning method. Let's save the file and let's go back to editor. Now let's test it, so press play. Now in our scene view we can see the winning sprite is the two horseshoes. So let's scratch them. And we can see after we scratch the second one, we see the winning sprite mask appeared on both of them. So we fix it. Now let's exit the play mode. And let's open our ticket script. And we want to assign random value to our show any sprite variable. So let's scroll up to our prepare ticket method. And here let's write item.showAnySprite equals to, and we need to create this new method. And we will do it inside utility. So let's open our utility script. And let's create new public static bool method with the name getRandomBool, and inside let's write return, and we will be directly returning system.convert.toBoolean, and the parameter will be random.range between 0 and 2. And why between 0 and 2? Because 0 is inclusive but the 2 is exclusive, so the random value will be only between 0 and 1. So let's go back to ticket and let's finish it. So item.showAnySprite equals to utility.getRandomBool, and let's do the same thing inside our else statement. So let's write section group.showAnySprite equals to utility.getRandomBool. Now let's save the file and let's go back to editor. Let's press play. And now we can see the bool value of show any sprite is false because we see the winning sprite. Let's scratch the ticket. And now the next ticket is showing the question mark, so random bool value was true. So that's exactly what we wanted. And also that's the end of this lesson. So thank you, and I'll see you in the next one. In this lesson, we will be assigning random colors to our ticket sections. First, let's open our database folder and let's open our settings database script. And here, let's change the type of our section enabled colors to be a list and also add suffix list to the name. Now let's switch to ticket script. Now we need to create temporary list variable, which will be always generated when we reset our ticket. So let's write private list of colors with the name color palette. And we need a copy of all our colors from the database. So inside reset ticket method, let's create color palette equals to our setting database dot instance dot section enabled color list dot toList. And the important thing is the toList method, which will create a copy of the list, not the reference to the list. And we need a copy because we will be choosing one color and also removing it from the list for each ticket section. Now inside our fill section color method, let's delete the old assignment and let's write utility.randomFromListRemove and let's put our color palette as a parameter. Now let's save the file and let's go back to editor. Let's select our database game object. Let's open our section enabled color list. Change the size to 6. And let's fill our first color, red channel 155, blue channel 255. Next, red channel 100, blue channel 255. Next, green channel 165, blue channel 255. Next, red channel 255, green channel 150. Next, red channel 255, green channel 255. And the last one, red channel 255, blue channel 200. Now we have nice colors, so let's test it. Let's press play. And we can see we are getting random colors. But what I don't like is that they are starting all at once, but we can fix it very easily. So let's select our board folder and let's open our ticket section group script. And here inside process all advanced ticket method, let's add some wait time to our coroutine. So at the end, let's write 0.1 and let's save the file and let's go back to editor. Let's press play. And now we can see our sections are enabled with a slight offset, which look much nicer. And that's everything for this lesson. So thank you, and I'll see you in the next one. In this lesson, we will be creating ticket holder script, which will be providing us random ticket always when we finish the old one. So inside our board folder, let's create new C# script. And let's call it ticket holder. Let's open it. Let's clean the file. And let's create first variable called public list of tickets with the name myTickets. Next, we need a method for activating random ticket. So let's write public ticket activate random ticket. And before we want to activate random ticket, we want to first deactivate all of them. So let's create public void deactivate all tickets method. So let's create for each loop where we will be looping over myTickets, and let's make each of ticket disabled. So let's write item.gameObject.setActive to be false. Now inside activate random ticket method, first let's call deactivate all the tickets method, and then we need to choose one random. So let's call ticket myTicket equals to utility.randomFromList, and let's put myTickets variable into parameter. So now we have one ticket, and now we want to activate it. So let's write myTicket.gameObject.setActive to be true. And also we would like to return it. So let's return myTicket. Now let's add a start method, which will be deactivating all the tickets at start. Now let's open Game Manager script. Here we need to create public ticket holder variable with the name ticket holder. And let's change the access modifier of our current ticket to be private because we don't need to see it inside inspector anymore. And inside update ticket settings, let's write current ticket equals to ticket holder dot activate random ticket, and let's save the file. Now let's go back to inspector, select the canvas, let's create new empty game object, let's move it under the background image, let's change the name to ticket holder, let's add ticket holder component on it, select our ticket C and turn it off. Let's select all our tickets and put them under our ticket holder. Now let's select our ticket holder and let's open my tickets value. Log the inspector and select all 3 tickets and let's drag and drop them to our my tickets variable. Now let's unlock the inspector back. Now let's open the managers, and inside game manager let's fill the ticket holder variable. So let's drag and drop it. And now we can press play. And we can see every time we finish a ticket, we will get new random one. So that's exactly what we wanted. Now we can exit the play mode. Now we would like to put the final values of our settings to our database. So let's select it. First, let's change the size of win 1x1 ticket count to 2. And let's change first element to 4. So we get a random number between 4 or 5 winning sprites to find. And then let's change the second element on win count all advanced ticket to 3. Then let's change size of money prize list to 3 and change the second element price to 50 and third element price to 100. For probabilities, let's change first one to 0.5, so we have only 50% chance to win the prize. Then let's change second one to 0.25, so we have 25% chance. And finally, the third one, let's change it for 0.1, so we will have only 10% chance to win 100th prize. Now for bonus prize list, let's also change it to 3 prizes and change the second prize to 10 points and third prize to 50 points. Let's again change the probability, so first will be 0.5, second will be 0.25, and the last one will be 0.1. Now let's finalize the materials. So let's open materials and shader folder, and let's click on our UI main scratch area material. And let's change the pattern scale to be 0.003. And also we can't forget to fix our samples because now they are visible, but in a final game we don't want them to be visible. So let's select our board folder and let's open sample script. And here we can just comment out reset sample method because we don't want the colors to show up. And also inside visit samples, let's cut the line which clear the color of the image, and let's paste it inside our awake method so the image will be initially empty. Let's save the file. Now we need to fix a board image script because this one was calling our reset function which we deleted. So let's open it. And here we can comment out all for each loop. Let's save the file and let's go back to editor. Let's press play. And now we can test almost final game. The last things we are missing is the main menu and also the animations, which we'll be doing in the following lessons. But so far, everything works how we wanted. So for now, this is everything. So thank you, and I'll see you in the next lesson. In this video, we will be creating a game menu. So let's select canvas. Let's create a new game object. Let's change it to be stretched. Let's rename it to the gameplay, and let's move it under our background image. And let's put our ticket holder under the gameplay, our scoreboard, and our winning panel as well. Now we would like to import our main menu asset. So let's import a package, select our main menu, and let's import all the files. Now from prefab for import folder, let's drag and drop our prefab under the canvas. Let's right click on it and let's press unpack package completely, and let's delete the prefab for import folder. Now let's turn off the gameplay game object so we can see only the main menu. Now inside the managers folder, let's create new C# script and let's call it main menu manager. Let's open the file. Let's clean it. And first we need static reference to our main menu manager. So let's write public static main menu manager with the name instance. And let's create awake method, and inside we will ask if instance equals to null, and if yes, our instance will equals to this main menu manager. Next we need reference to our main menu parent game object. So let's write public game object main menu parent, and also to our gameplay parent. So let's write public game object gameplay parent. Now when we start our game, we want to start with the main menu. So inside our awake method, let's first turn on our main menu parent. So let's write main menu parent dot set active to be true. And also we would like to hide the gameplay parent because this one will be visible only after we press the menu button. So let's write gameplay parent dot set active to be false. Now we need a coroutine which will be waiting for our menu button to be clicked. So let's create public IEnumerator wait until clicked. And for this coroutine, we need to define new variable. So let's write bool menu clicked equals to false. And inside our coroutine, let's assign menu click to be false every time when we start it. And then let's create while loop where we are asking if our menu clicked is still false. And if is, we want to yield return null. So basically we are waiting until menu clicked is true. And when it finally is, we want to hide our menu. So let's write main menu parent dot set active to be false. Then we want to wait half a second. So let's write yield return new, wait for a second, and let's put 0.5 as a parameter. And finally, we want to show our ticket. So let's write gameplay parent dot set active to be true. And the last thing will be yield return null. So our gameplay parent will have a time to show up. Now for our button, we need to one more method. So let's write public void clicked. And inside, let's write menu clicked to be true. Let's save the file and let's go back to editor. Open the managers. Let's create new game object. Let's rename it to main menu manager. And let's drag and drop main menu manager component on it. And let's fill the variables. Main menu parent will be main menu, and gameplay parent will be gameplay. And for our button, let's use our button manager. Let's change the size of the buttons to be 2. Let's change the name to be play button. And let's fill my button variable. So let's open the main menu parent, open the parent button, and let's drag and drop button play into my button variable. Now let's delete the old event and let's create a new one. And for the new one, we need to drag and drop our main menu manager on it. And from the function list, let's choose main menu manager and let's choose method called click. Now to include our main menu to our game loop, let's open our game manager. And in the start method, let's add one yield return statement where we are calling main menu manager.instance.wait until clicked. And this coroutine will basically display our menu and it will be waiting until we clicked on a button. But we have an error because we can call coroutines only from the coroutines, and our start method have a return type of void. But luckily, inside Unity, we can use star method as a coroutine. So let's change the void to be IEnumerator. And then now everything will work. So save the file and let's go back to editor. Now press play. And we can see nothing happen unless we click on our hand button and our gameplay will start. So that's everything for this lesson. Thank you, and I'll see you in the next one. In this lesson, we will be creating animation system, which will be driving all animations in our game. To start, let's first disable our game. So let's select our manager's game object and let's turn it off. Then let's open our canvas. Then let's select our gameplay game object and let's turn that off. Now let's select our main menu game object and let's turn that on, because we will be doing all our animation tests first on our main menu. Now we want to create our animation system. So let's select our scripts folder and let's create a new folder and let's call it animation system. And inside, let's create a new C# script and let's call it animclipplayer. Let's open it, clean the file. We need to create one more class. So let's write public class animclipSettings and let's add system.serializable so we can see all the values inside inspector. Now inside our new class, we want to define which game object we want to animate. So let's create public game object object. And also we want to define animation clip, which we want to play. So let's create public animation clip animation. Now inside our animclipplayer, let's create new coroutine. So let's write private IEnumerator play clip wait to finish. So basically when our coroutine finished, we know that our animation finished as well. And in the parameter, let's add our animclipSettings, clip settings. Now to drive our animation from coroutine, we need to have a time variable. So let's create float current time with the default value of 0. Then we need while loop with a true as a parameter. So right now it will be never-ending loop. Then we need to increment our current time. So let's write current time plus equals to time.delta time. And finally, to drive our animation, we need an access to our animation clip. So let's write clipSettings.animation and let's use the sample animation method, which any animation clip provides. And it needs the game object and animation time as a parameter. So let's write clipSettings.object as a first parameter and our current time as a second. Now let's create if statement where we are asking if our current time divide the length of the animation, which is stored inside clipSettings.animation.length is more or equals to 1. So basically we are asking if animation already finished, and if yes, we want to stop our never-ending while loop, so just write yield break. Now if our animation didn't finish yet, we want to continue inside our loop, so just write yield return null. Now let's create public variable of type animclipSettings with the name animclip, so we can fill our game object with animation inside inspector. And also let's create a method for starting our animation. So let's write void start playback, and inside let's write start coroutine. And for the parameter, let's use our play clip way to finish coroutine, and its parameter will be animclip. But this method we want only for testing purposes. So let's add attribute with the name context menu with a string start playback, so we can access this method from the inspector, and also create a second method called stop playback, so we can also stop our animation for some reason. And inside the method, let's write stop all coroutines. So all coroutines which are driving this animation will be stopped, so the animation no longer will be playing. Also, let's create the attribute. So let's write context menu, and the parameter will be string with the name stop playback. Save the file. Let's go to our inspector. And for testing purposes, let's create a new game object. Let's name it clip player. Let's reset the transform. Let's drag and drop our anim clip player component on it. And now let's fill the variables. So let's open our main menu and let's drag and drop our button play into our object variable. Now we need to create animation clip. So first let's select our button play game object. Now let's select our animation window, grab it, and let's move it down so we have bigger workspace. Now let's press create. Let's create a new folder called animations. And inside, let's create a new one with the name scale up. Press save. Now we need to add property to our animation, which will be the scale property. And let's open it. Let's change the first frame to be 0. And when we scrub the timeline, we can see the scale of object is increasing. Now let's select our button play game object again, and we can delete the animator component because we will not using it. We are writing our own animation system. Now we can fill our animation variable. So let's select our clip player game object and let's click on pick button and let's select our scale up animation from the list. Now to test it, let's press play. Now to test our animation, just click on the 3 dots on our anim clip player script and select start playback, and we can see our animation is working. So let's do it again and we can see everything is working. So let's exit the play mode. Let's open our anim clip player script again and we will be adding new features. First feature we would like to add is controlling the speed of our animation. So inside our anim clip setting class, let's create public float speed with a default value of 1. And inside our playback coroutine, let's multiply our current time with the clip settings.speed. And inside the if statement, let's also multiply our current time with the same clip settings.speed. Now let's save the file and let's go back to editor. And for testing purposes, let's change the speed to 0.1. Press play. And let's try start playback. And we can see the speed of animation is slow. We can also try to press stop animation and the animation stopped. Let's turn playback again and we can see everything works. So let's exit the play mode. So let's go back to our anim clip player. And we will be adding a new feature, which will be a looping possibility for our animation. And we will be supporting loop type ping pong and loop type repeat. So let's create public enum loop type, and inside let's write 3 options. First will be play once, where our animation didn't support any looping. Then let's write ping pong, where we want to our animation repeat in a ping pong way. And the third option is repeat, where we want our animation to be repeated over and over. Now inside anim clip settings, let's add new variable. So let's write public loop type. And for working with these loops, we need to create new method with a return time float, and the name will be process time. And this method will be modifying our current time with our looping options. And the method will have 2 parameters. First will be float current time, and second will be anim clip settings. Now inside our play coroutine, let's cut current time times clip settings.speed and let's paste it to our process time, and let's switch it with our process time method, and let's put current time as a first parameter and clip settings as a second. Now let's fix our process time method. So let's create if statement where we are asking if clip settings.loopType equals to loopType.playOnce, and if yes, let's return our old statement. Now for our second option, let's duplicate the line and let's change loop type to repeat, and we want to return madf.repeat, and let's put our current time.clip settings.speed inside the brackets, and the second parameter we need length of our animation, so let's write clip settings.animation.length. Now for last option, let's copy the line again. Let's change loop type ping pong, and let's change mathf value to be ping pong, and we can see our process time method have a still error because we need to return some value if all these options are not valid. So just write return 0. Now inside our play method, let's ask if clipSettings.loopType equals to loopType.playAdvance, and if yes, let's put inside our if statement. And the reason is when we are playing the animation only once, it needs to stop when it finishes. But our other loop types are basically looping forever until we stop them manually. Now let's save the file and let's go back to editor. Here we can see our default loop type is play advance. So let's change speed to 1 and let's press play. Now let's start playback and we can see it's worked normally. Now let's change loop type to ping pong and let's start playback. And we see our animation in looping. So let's stop it. Now let's change loop type to repeat and let's press play and we see our animation is looping in a repeated way. So that's working. Let's exit the play mode and let's go back to our AnimClip player. Now inside AnimClip settings, we will be adding two internal variables. So the first one will be internal float anim time, and second will be internal float anim time normalized. And why we are using internal axis modifier? Because they are not visible inside inspector unless we turn on the debug mode. Now let's scroll down to our process time method, and instead of returning our values, let's assign them to our clipSettings.animType, and let's do it in all our cases. And at the end, let's just return our clipSettings.animTime. Now let's also fill our clipSettings.animTime normalize, and our normalized suffix means that the time value goes from 0 to 1. So let's write equals to clipSettings.animTime divide clipSettings.animation.length. Now when we check to our play coroutine, we are using the same statement inside our if condition, so we can delete it and replace it with our clipSettings.animTime normalized. So we optimized our code a little bit. Now let's add another feature. And what we want is to have an option to skip the animation playback when our animation already finished. So when we try to play animation which was already played, it will not work. So to do it, let's add one parameter into our playClipWaitToFinish method, and it will be bool skip if done. And let's ask if skip if done equals to true, and then we need to ask if our clipSettings.loopType equals to loopType.playOnce, because this feature will work only for our playOnce loop type. And now we need to ask if our animation was already played, so just ask if clipSettings.animTime normalize was more or equals to 1. And if yes, we will break from our coroutine, so let's just write yelp break. Now to fix our start playback function, let's change the default value to be false. Now when we want to start our method with a skip if done option, let's copy our start playback method and let's add true to the parameter, and let's change the method name to be start playback skip if done, and let's also change the context menu to start playback skip if done. Let's save the file and let's go back to editor. Press play and let's start our playback. We can see it is working. We can do it again with the start playback and we can see the animation start again. But now let's press start playback skip if done, and we can see we don't get any animation because animation was already played. So this is working. So let's exit the play mode, and that's it for this lesson. So thank you, and we will continue in the next one. In this lesson, we will continue to finish our animation system. So let's open the AnimClip player script. Now the next feature which we can add is when we start our game, we can initialize first frame of the animation. So inside AnimClip settings, let's add public bool evaluate on enable with the default value of false. And inside AnimClip player, let's create on enable method. And here we can ask if AnimClip.evaluate on enable equals to true. And if yes, let's write new method called evaluate anim curve beginning. Let's generate this method, change it to public, delete the exception, and let's write AnimClip.animation.sampleAnimation, and as a parameter will be our AnimClip.object, and for the time parameter will be process time, and the parameter of process time will be 0, and the second parameter will be AnimClip. Let's save the file, and let's go back to editor. Now when we check evaluate on enable to be true, and when we press play, our animation jump to our first frame. So this is working. Now let's switch back to our AnimClip player. Now the next feature will be possibility to automatically play our animation when game object will be enabled. So we need new variable. So let's write public bool play on enable with a default value of false. Now inside on enable method, let's write if play on enable equals to true. We would like to start our coroutine, and the parameter is basically our play clip way to finish method with AnimClip as a parameter. Let's save the file. Let's go back to editor. Now let's check our play on enable variable. Let's press play. And we can see the animation was played automatically. Let's exit the play mode and let's open our AnimClip player script. Now the next feature will be instead of playing one animation clip, let's create a list of our animation clips so we can play more animations at once. So let's change our AnimClip to be a list of AnimClip settings, and the name, let's change it for AnimClips. And also let's assign empty list to it. So let's write equals to new list of AnimClip settings. Now let's fix the errors. First, inside our onEnable method, let's create for each loop where we will be looping over our animation clips. So let's change item to AnimClip, and let's change collection to AnimClips, and let's copy the line and let's paste it inside. Now let's fix our evaluate anim curve beginning method. So let's create for each loop where we will be looping again AnimClip in AnimClips. And let's copy and paste our line inside the if statement. At the end, let's fix our playback methods. So we need a new coroutine. So let's write public iEnumerator play, and let's put bool skip if done with the default value of false as a parameter. Now inside the coroutine, let's create list of iEnumerators with the name animRoutines, which will equals to new list of iEnumerators. And then let's create for each loop where we are looping our AnimClip in AnimClips. And inside, let's add all our coroutines to our new list. So let's write animRoutines.add. And let's put play clip way to finish. And the first parameter will be AnimClip, and the second will be skip if done. Now, when we have all playback coroutines inside one list, we can play them all at once with our old method. So let's write yield return utility.run coroutines all at once way to finish, and let's put this as a first parameter and our animRoutines list as a second. Now we can finally fix our start playback method. So let's delete the old coroutine and replace it with the play one. And inside our playback skip if done, let's do the same, but let's use our play coroutine with a true as a parameter. Now let's scroll up and let's also fix our last error, and let's do the same, delete the old coroutine and let's replace it with a play one. Now let's save the file and let's go back to editor. Here let's open our AnimClips list and let's change the size to 1, and let's open the element. And we can see small error. Our speed value have a default value of 1, but we can see 0 instead. So to fix it, let's go back to our AnimClip player script. And to make it work, we need to add to our AnimClips initial value So let's add one instance of our AnimClip settings class to the list. So just write curly brackets and inside new AnimClip settings. Now let's save the file and let's go back to editor. Let's first remove our old AnimClip player and let's add new one. And we can see our list is already with a size 1, but the speed value has a default value of 1, exactly how we want it. So let's test it. First, let's fill our object variable. So let's drag and drop our image game object onto it. And for the animation, let's choose our scale up. Let's check evaluate on enable, and let's also check play on enable. And let's press play. And we can see the animation is working. Now let's change the AnimClip size to 2. And let's drag and drop our button play game object onto second object variable. Let's press play. And we can see both animations are working. So that's exactly what we wanted. Now let's go back to our AnimClip player. Now let's create option where we can offset animations inside list. So let's create public float weight in between with a default value of 0. And let's also add space attribute. So we will have nice visual space inside editor. Now let's scroll down to our play coroutine and let's add weight in between parameter to our utility run coroutines all advanced method. So now we can have offsets between our animations. Now let's scroll up to our AnimClip settings class and let's add new variable. So let's write public string name and let's also add a height in inspector attribute. And the cool thing about name variable inside any class is when we put this class inside a list and we assign some string to our name variable, it will also change the element name inside the editor. Now in our case, we would like to assign GameObject name to our name variable. So for this purpose, inside our AnimClip player, we need to create new onValidate method where we will create new for each loop where we will be looping our AnimClip inside AnimClips. And first we need to ask if our game object which we want to animate exists. So let's write if AnimClip.object doesn't equal to null, and if not, let's write AnimClip.name equals to AnimClip.object.name. And the question might be why we are using onValidate method. And the reason is simple. onValidate method will always run when we change some value inside inspector. So for example, when we assign new game object to our AnimClips list, this method gets triggered and we get name updated automatically. So let's save the file and let's go back to editor. And we can see the names of elements changed. So now they are named by our game object names. Now let's test our weight in between value. So let's change it to 0.2 and let's press play. And we can see our animations have slight offsets, so everything works. Let's exit the play mode and let's go back to our AnimClip player. Now the last thing we would like to add is a preview feature. So we can see inside editor how the animation will look. So let's create public float test progress variable. And let's create a range attribute between 0 and 1. So our test progress variable will have a slider which can move between 0 and 1 as well. Now inside the onValidate method, we need to ask if we are inside the editor, because we will be using editor only features which we can't use in a build. So let's ask if not editor application, and let's also add a namespace using Unity editor. And let's continue. So we are asking if not editor application is playing. That means we are inside editor. And if it's true, let's write animation mode.start animation mode. And this mode will allow us to see the animation. And let's loop over our AnimClips. And let's ask if AnimClip.animation doesn't equals to null. That means we have some animation assigned. And if we have some animation, let's call animation mode.sample animation clip. And let's put AnimClip.object as a first parameter, AnimClip time.animation as a second parameter, and for the time we need to create new method which will be processing our animation between 0 and 1. So let's write process progress, and our first parameter will be test progress value, and our second parameter will be our anim clip. So let's generate this method. Let's delete the exception, and let's write animclip.animetime equals to test progress times animclip.animation.length, and we need to return it, so just write return animclip.animetime. Now let's continue inside our onValidate method. Let's ask if test progress equals to 0. That means we would like to turn off the preview and go back to our initial values. So let's write animation mode.begin sampling, then animation mode.end sampling, and finally animation mode.stop animation mode. And basically we need these three methods to stop our animation preview. Now, just for safety, inside our onEnable method, just reset our test progress to be 0. So when we enable our game object, there will be no preview going on. Now save the file. Let's go back to editor. And we can see we have a slider, and when we slide it, we can see the animations. And when we go back to 0, our game objects jumps into initial values. So it's working great. Now let's open our animclip player again. And the last thing, we need to be sure that we can build our game, because we are using Unity Editor namespace, and we can't build with a Unity Editor namespace anywhere in our script. So just on top of our Unity Editor namespace, we need to use platform define directives. So let's write hashtag if Unity_editor. And under our Unity Engine namespace, just write hashtag and if. Now let's scroll down to our onValidate method, and let's do the same. On top of our if statement, let's write hashtag if Unity_editor. And after it, just write hashtag and if. Now let's save the file, and let's go back to editor. And we finally finished our animation system, and we can animate our game easily. So that's everything for this lesson. So thank you, and I'll see you in the next one. In this video, we will be creating menu animation. So let's open the canvas, open a main menu. Let's create a new game object, and let's name it animations. Inside, let's create new game object, and let's call it in for in animations. Let's add our animclip player component. Select our in-game object, and let's duplicate it once and change the name to idle. And let's duplicate it second time, and let's change the name to out. Now select our int game object, change size to 2 objects, drag and drop image to object 1, change animation to scale up. Now let's drag and drop parent button to the second object and change animation to also scale up. Now check evaluate on enable on both of objects, and weight in between, let's change to 0.25. Now let's preview our animation, and it's working exactly how we want. Now select our idle game object, drag and drop our button play to our object, and select our button play game object, and we need to create new animation. So let's save it inside assets animations, and the name will be scale up and down. Now let's add a property, and the property will be scale. Select our frame 30 and change the scale of each axis to be 1.2. And we can see, scrubbing the timeline, how it will be growing and shrinking. Now let's delete the animator, we don't need it anymore. Select back our idle game object, and let's choose our scale up and down animation, and change the loop type to be repeat. change the speed to 1.5 and let's check play on enable and let's test it. It's working nice. And the last game object, let's select the out one, change the size to be 2, select the first will be parent button and the second animation will be for image. Now for the image, we need to create new animation, so select the image. Let's create new one and let's change the name to scale down. Let's add property. The property will be scale. Let's scrub to the last frame and change the scale values to be 0 on all the axes. Now delete the animator. Let's select out game object and let's choose our scale down animation, and also for our image let's choose our scale down animation. Test it, it's working also great. So let's change weight in between to 0.25 and also let's change the speed to 1.5 on both of objects. Now we need to hook our animations to our gameplay. So let's open our Main Menu Manager and let's add public anim clip player anim in and also public anim clip player anim out. Now inside our wait until clicked coroutine, let's start our routine with the yield return anim in dot play. And right before we are deactivating our main menu parent, let's run another coroutine with the yield return anim out dot play. So now the animation will work how we want. Let's save the file. Let's go back to editor. Let's turn on the manager's game object again. Let's select our main menu manager and let's fill our anim in with the in-game object and anim out with the out-game object from the main menu animations. And let's press play. And we can see we have nice main menu animations, and when we press our game, we can play it. So that's everything for this lesson. So thank you, and I'll see you in the next one. In this video, we will be creating ticket section animations. So let's open a canvas. Let's select our main menu. Let's turn it off. Let's select our gameplay and let's turn that one on. Open our gameplay. Select our ticket B, for example, and let's turn that on. Now let's open it. Let's open the ticket section parent prefab. Select the ticket section parent and let's create new game object. Let's rename it to animations. Let's create new one. Let's call it in. And let's add our anim clip player on it. Now let's duplicate it and rename the second one to be out. Now select our in-game object and let's fill our animation object to be ticket section, and let's fill the animation to be scale up, and also check evaluate on enable, and let's change speed to be 2. Select our out animation game object. Let's fill the same ticket section to the object variable and fill animation to be scaled down. You can also try it, it's working nicely. For the speed, let's use value of 2 and let's select our ticket section game object and let's open the ticket section script. And here we need to reference our animations. So let's create public anim clip player called anim in and also public anim clip player anim out. Let's also create header and let's use a string animations for it. Let's save the file and let's go back to editor. And here we want to fill it. So let's drag and drop our in game object to anim in and our out game object to anim out. Let's go out from the prefab, select the ticket script. Let's open it. And inside process ticket method, we would like to run our animations. So let's write yield return, and we would like to run our animations all at once. So let's write utility.run coroutines all at once wait to finish. And first parameter will be this, and second one will be ticket areas dot select. So we are using a link statement for selecting multiple coroutines, and inside we have to create lambda expression. So let's write a lambda operator a dot animin dot play, and at the end let's put it to the list, and the last parameter will be wait in between time, which we put 0.1 second. So our section animations will have slight offset, which will be much nicer. Now let's duplicate this line to the end, and we want to change the name to be anim out. So when we scratch our ticket, we want to play the out animation, but we want it to play in reverse order. So let's add .reverse method, and our animation list will be reversed. Let's save the file, and let's go back to editor. And let's press play. And when we click on our icon, we can see that our ticket areas are appearing one by one. And when we finish our ticket, they are also disappearing one by one. But I see one problem which we want to fix, and that is the appearing of the colors. They are appearing very fast from frame to frame, and it will be much nicer if this transition will be smoother. So let's exit the play mode. Let's open our utility folder, and let's open our utility script. And here we need to add coroutine, which will be changing our colors. So let's write public static iEnumerator, and the name will be lerp between two colors. Lerp stands for linear interpolation, and inside we want three parameters. First one will be image, because we are changing color of the image. But first, let's add unityengine.ui namespace, and the name will be my image. The second parameter will be color, toColor, and the third parameter will be float in time. So we are defining how many seconds this transition will last. Now, first thing, we need to define time variable. So let's write float elapsed time equals to 0. Then color from color will equals to my image.color, and by default my image.color is the gray color, which we are setting as a disabled color inside the database. And then let's create a while loop where we are looping while elapsed time is less than our in time. If the condition is true, let's create color, new color equals to color.lerp between from color to toColor, and in elapsed time divide in time, which will always give us the actual time between 0 and 1. Now let's assign our new calculated color into my image. So let's write my image.color equals to new color. Now let's also change our elapsed time. So let's increment it by time.delta time. And let's finish the while loop with a yield return null. And let's finish our coroutine with myImage.color equals to toColor. Save the file. Now we need to implement it inside our scratching area script. So let's open it. And here, when we are enable scratching, we would like to use this animation. So let's delete the last line and replace it with a yield return utility.lerp between two colors. And as a parameters, let's use scratch image as the first one, BG color as the second one, and 0.5 as the last one. Now we see our method is not coroutine, so let's change void to iEnumerator. Now we need to fix also our ticket section script, so let's open that one. And here let's find wait until scratching finish coroutine. And here we are using the enable scratching method, which is now coroutine. So now if we want to run it, we just need to write yield return in front of it. So we fixed it. Let's save the file and let's go back to editor. Now let's try it. And we can see our colors are slowly appearing how we wanted. So there is not hard animation. It's exactly how we wanted. So that's everything for this lesson. So thank you, and I'll see you in the next one. In this video, we will be creating scoreboard animation. So let's open the canvas, open the gameplay, open a scoreboard, select the scoreboard, and let's create new game object, and let's rename it to animations. Inside, let's create new game object, add anim clip player. Let's duplicate it 5 more times. And let's rename first one to main in. Now we would like to fill the animation object, so let's drag and drop main panel on it. And let's change the animation to scale up. Let's check evaluate on enable and change speed to be 0.5. Now let's test it, and it is working nice. Now let's select second animation object and let's change the name to add-on in. And here let's change size of our animation clips to 2. Let's fill the first game object to be add-on panel, and let's drag and drop our winning sprite panel as a second animation object. Now for the second one, change the animation to scale up. And for the add-on panel, we need to create new animation. So let's select add-on panel. Let's drag and drop our animation window to be down near the console, and let's create new animation clip. Let's go to assets, animations, and let's change the name to scale Y up, because we want to scale only in a Y axis. Press save. Now add property, open rect transform, and select our scale. Open the scale, and let's select X-axis keyframe and delete it, Z-axis keyframe and delete it, and also at the end do the same. Now let's go to the frame 0 and let's change the Y value to be 0. And we can see our panel is scaling how we want it. Now let's create new clip and let's call it scale Y down. Add property, select a scale. Let's delete the keyframes for X and Z. And let's scrub to the last frame, which is frame 60, select the keyframe, and let's change the Y value to be 0. Now we can see the panel is shrinking how we want it. Now we don't need animator anymore, so let's remove the component. Now let's go back to our add-on in animation, and let's fill the animation variable, and let's choose scale up. Now let's check evaluate on enable on both animations, and let's change speed to 0.5 also on both of them. And let's test it, and we can see we accidentally choose different animations, so let's fix it. Let's choose our animation for add-on panel to be scale Y up instead. Now it's working. Now select our next animation game object, and let's change the name to add-on out. Change the size of clips to be 2. And let's fill the first object to be winning sprite panel and the second one to be add-on panel. Let's change the animation of the first object to be scale down. And let's change the animation of second object to be scale Y down. Now adjust the speed to be 0.5 for the both of game objects. And let's test it. And we see everything works how we want it. And the last thing, let's change weight in between value to be 0.1. So there will be slight offset. And we can do the same inside add-on in game object, so the animation will not start all at once. Now let's select our next game object for animation, and let's rename it to number in. And let's drag and drop our panel number onto the object variable. And for the animation, let's choose scale up. Let's check evaluate on enable, test the progress, and it's exactly how we want. So now let's select the next game object, and let's change the name to number out. Let's fill the panel number into the object variable, and the animation will be scale down. We can test it, and the scaling is working nicely. Adjust the speed to be 0.5. Do the same for the number in, so they will be a little slower. And now select the last game object. And this one, let's rename to idle. So here we will be preparing the idle animations. And we want to use two game objects. And first will be inside winning sprite panel. Let's drag and drop parent game object. And inside our panel number, let's drag and drop parent game object on a second object. Now change the animation to be scale up and down for both of them. And let's change weight in between to 0.1. Change the loop type to be repeat for both of them. And also check play on enable. Now we can try it, and it is working perfectly. Now our animations are prepared. Let's hook them to our gameplay. So let's open our managers and let's click on Scoreboard Manager. And let's open Scoreboard Manager script. And let's add public anim clip player called anim main in variable. Let's duplicate it 4 more times. Let's change the name of the next one to be anim addon in. Next will be anim addon out. Next is number in, and the last one will be number out. Let's create a header and let's add animations string to it. Let's save the file. Let's go back to editor, click on Scoreboard Manager, and let's fill our animations. Now select board and let's open ticket script. Here we need to create the list where we will be storing our animations. So let's create list of iEnumerator with the name ticket animation routines, which will equals to new list of iEnumerators. And let's fill our first member to be scoreboard manager.instance.animMainIn.play. And let's put true as a parameter. That means we want our main panel in animation to be played only once. So when our main panel will appear, we don't want to hide it anymore and play it again. Next, let's add to our ticket animation routines our old ticket areas animations. So let's select them from our run coroutines all at once method. And let's put them to our addRange method on our ticket animation routines list, where addRange is adding multiple animations to the list instead of only one. And the last step, let's use our ticket animation routines and let's put it to our run coroutines all at once method. So our coroutine will also use our main menu animation to show up with our ticket areas animations. So now we need to play our animation add-on. So let's open process one by one section and let's add yield return scoreboard manager.instance.animAddonIn.play. Now we want to run our number panel, but only if our area type is money. So let's write if item.winsettings.type equals to area type.money. Let's write yield return scoreboard manager.instance.animNumberIn.play. Now we need to implement our out animations. We can do it inside finish processing method. So at the end, let's ask if winningsettings.type equals area type.money. And if yes, we want to hide our number panel. So let's write yield return scoreboard manager.instance.animNumberOut.play. And also we would like to run out animation of our anim add-on. So let's write yield return scoreboard manager.instance.animAddonOut.play. Now let's go to our ticket section group, and here we need to do the same for our process one by one ticket and process all at once ticket. So we can create one coroutine which will handle both of cases. So let's create yield return begin section group processing, and let's put ticket as a parameter. Let's put this method also to the second process all at once method. Let's generate this method, delete the exception. Let's change the return type to be iEnumerator. And we can also put our star coroutine inside it because we are sharing the same method in both of our methods. So let's delete it from the second one. And now let's add our animations. So let's write yield return scoreboard manager dot instance dot anim addon in dot play. So first we are showing the animation addon. Then we are asking if win settings dot type equals to area type dot money. So let's write yield return scoreboard manager dot instance dot anim number in dot play. And let's go back to ticket. And let's delete our yield return new wait for a second because we don't need it anymore. It was only slowing down our gameplay. Let's save the files and let's go back to editor. Let's press play. And we can see our scoreboard animation is appearing. It's a little slower. So let's exit the play mode. So first let's select number out animation and let's change the speed to 1.5. Then let's select number in and let's do the same. Then let's select add-on out and also let's change speeds to 1.5 for both of animations and let's do the same for add-on in. And also the last one is main in and let's also use 1.5 for the speed. Let's press play to test it again. Now we can see the animation is much faster and is working great. So let's exit the play mode. Now let's open ticket holder, select ticket section parent. Let's open the prefab. So first select our out animation and let's change the speed to 1.25 and let's do the same for our in animation. Let's exit the prefab. Now press play. And now it looks a lot better. Now we can enhance our animations even more. Let's select our animations folder. First, let's clean the controllers because we are not using animators. So let's select all the controllers and let's delete them. And let's select our scale up animation. Let's display curves. And here we would like to change easing of the curve. So let's click on frame 50 and let's right click on a curve and let's write add key. And let's change the key to be 1.1 in all axes. And let's select also scale down animation. Here let's go to frame 10. Let's add a key and let's change it again in 1.1 in all axes. And now our animations will be much smoother. So let's test it. They are a lot smoother when they are growing and when they are shrinking. So everything works great. We can exit the play mode. And that's basically everything for this lesson. So thank you and I'll see you in the next one. In this lesson, we will be creating animations for our winning sprites. Now we need to open our board image and the easiest way is select our prefabs and select our board image and let's open the prefab. Now let's select our winning image rotate and here we will be creating new empty game object and let's rename it to animations. Inside let's create new empty game object. Let's add an in-clip player component on it and let's duplicate it 2 more times. Select first one and let's rename it to in. Now to fill the animation game object, let's drag and drop our winning image scale up on it. And let's change the animation to be scale up. You can try it. And we can see the mask is slowly appearing. Then let's check, evaluate on enable. So this animation will automatically play when our winning image will be enabled. Then let's select the second game object and let's change the name to idle. Here we will be filling the idle animations. So let's change anim clip size to 2. Now let's fill our objects, and first will be winning image rotate. So we'll be rotating our mask. Also, we want to animate our image main game object. And for this one, let's choose already made scale up and down animation. And now let's create the rotation. So let's select winning image rotate game object. Let's create new animation. Let's save it inside assets animations and let's name it rotate 360. Now add property, open rect transform and choose rotation. And we want to rotate only on a Z axis. So let's delete the X and Y keyframes. Now let's drag the slider to the last frame, which is frame 60, and select the keyframe, and let's change the rotation Z value to be 360. And when we are scrubbing timeline, we can see the animation is working how we want. Only what we want is to change the easing. So let's select both frames and let's change both tangents to be linear because we don't want any easing, we just want rotation loop. Now we can remove the animator. Let's select our idle game object and let's choose the animation to be rotate 360. Test the progress and we can see the game object is also scaling up and down and also mask is rotating. Now change the speed for rotation to be 0.1 and let's check play on enable. And let's change our loop types to be repeat for both of our objects. Now let's select our last game object and let's rename it to out. And let's drag and drop our winning image scale up into our object variable and let's choose scale down for the animation and change the speed for 2. And the mask is shrinking nicely. Now let's select our board image and let's open board image script. And here let's add our animation. So let's write public anim clip player win anim in and also public anim clip player win anim out. And let's add a header with the name animations. Save the file and let's go back to editor. And let's fill our win anim in and our win anim out. Let's go back to our board image. And here inside our method check if finished and showing, let's extend our if statement. And at the end, let's write yield return win anim in dot play. And let's go to our ticket script. And here inside our finish processing method, we want to have a control of our winning animation. So instead of using our show winning method, let's delete our for each loop entirely. And we want to yield return new coroutine with the name play board images win animation in. And let's put our section list as a parameter. And let's generate this method. Delete the exception. Now we need to store all the coroutines which we was using in the deleted show winning method. So let's create new list of IEnumerator called board images anim in list, which will equals to section list dot select many. And we know that select many is joining multiple collections into one collection. And what we want first is a collection of all board images. So let's write lambda statement, a lambda operator, a.board image list, and we want our collections to be a list. So let's end it with a toList operator. And now we want to select from this list our coroutines. So let's write dot select And let's create second link statement with a b link operator b.check if finished and show winning. And at the end, again, we want our collection to be a list, so let's end it with a toList operator. So now we have all the coroutines from our multiple board images list inside the one board image anim list. Next, we want to run all these coroutines at once. So let's write yield return utility.run coroutines all at once wait to finish. And let's put this as a first parameter and our board images anim in list as a second. Let's fix the return type to be IEnumerator, and we basically finished our coroutine. Now for our winning out animations, let's go to our finish processing method, and we need to ask if show any sprite is equal to false, or if our win settings.did_I_won equals to true. And if the condition is true, we want to yield return again a new coroutine with the name play board images win animation out, and let's put section list as a parameter. Now let's generate this method, change the return type to be IEnumerator, and let's delete the exception. Now inside the method we need to store only the list with our winning board images. So let's create new list of board image with the name only winning board images, which will equals to section list dot select many. And let's again create lambda statement with a lambda operator a dot board image list, and we end it with a toList operator. And then we will create another link statement with the name where, and inside we need to define a condition. So let's write b lambda operator b dot is winning equals to true. That means we only want our winning board images included in our list. And at the end, we just want to create a list from our collections. So let's end it with a toList operator. Then again, we want a list from our animation coroutines. So let's write list of IEnumerator board images anim out list equals to only winning board images dot select, and inside let's put again a lambda statement a lambda operator a dot win anim out dot play, and let's end it with a toList operator. And now we can run our coroutines. So let's just write yield return utility dot run coroutines all at once wait to finish, and let's put this as a first parameter and board images anim out list as a second. Now when our animations are already played, we want to disable our winning game objects. So let's create for each loop where we are looping over only winning board images, and inside let's write item.winningGameObject.setActive to be false. Now we finish our second coroutine, so let's save the file and let's go back to editor. Let's exit our prefab, and we can press play to test it. Now we are looking for a card winning sprite, so let's find it. And we can see the nice animations of the winning sprites. Which is working exactly how we wanted. So that's everything for this lesson. So thank you, and I'll see you in the next one. In this video, we will be creating finish scratching animation. So let's press play to see what we want to achieve. Now, when we scratch and when we finish our section, there is a pop in animation which is clearing all the ticket area from scratching, and we would like to change it in a smooth animation. So let's exit the play mode. Let's open our prefab folder and let's open our board image prefab. Select the board image, let's create new game object, and let's change the name to Anim Scratch Finalize. Let's add our Anim Clip Player component on it. And now we don't have our object we want to animate. Because we want to modify our scratching, we need to use our projection camera, and our UI elements are already connected with our main camera. That's why we need to use a normal sprite for our animation object. So let's exit the prefab. First create new empty game object. Let's rename it to sprite. Reset the transform. And let's add sprite renderer component. And let's pick the sprite to be our panel fill. Now change the color of it to be red. And now we don't want it to be visible in our gameplay, so let's change the layer to be scratching, so it will be visible only for our projection camera. Now let's create prefab of it, so let's drag and drop it into our prefab folder. And let's delete the sprite from our hierarchy. Let's open our board image prefab again, and now let's drag and drop our sprite into the hierarchy. And let's select our board image and let's create new empty game object. Let's rename it to Finalize Scratching. And let's move our sprite under the Finalize Scratching parent. Now select our Finalize Scratching game object. Let's make it stretched. And let's add aspect ratio fitter because we want it to be always squared. So let's change aspect mode to be fit in parent. And let's change aspect ratio to be 1. Now let's click on our sprite and let's change the scale in all axes to be 500, so the sprite will be visible, because we know that the UI have different scale, so that's why we need to use this big value. Now let's select our Anim Scratch Finalize and let's drag and drop our Finalize Scratching into the object variable, and let's choose the animation and it will be scale up. Let's check evaluate on enable. And let's try our animation, and we see it is working very nice. Let's select our board image. Let's open board image script. And let's create a new variable called public anim clip player scratch finalize anim. Save the file. Let's go back to editor and let's fill this animation. Now let's open scratching area script. And inside finalize processing method, we want our animation to be played. So first let's rename this method to finish scratching because it makes more sense. Let's change the return type to be IEnumerator. And let's add list board image with the name board image list as a parameter. And now we want to play all these animations of the all board images from the one scratch area. So we need to gather them into one list and then let's play them at once. So let's write yield return utility.run coroutines all at once wait to finish. And let's put this as a first parameter. And the second one, we need to gather the list. So let's write board image list.select. And inside we need lambda expression. So let's write a lambda operator a dot scratch finalize anim dot play, and at the end let's write to list. Now under clear instance let's write for each loop, and we would like to loop over our board image list. And what we want to do after our animation is already played, we would like to reset it to the first frame. So let's write item dot scratch finalize anim dot evaluate anim curve beginning. Now let's open our ticket script, and we need to fix the finish scratching method. But first let's open our ticket section group script, and here we need to fix a similar error. So let's fix it by adding yield return in front of the statement, and also let's add item.boardImageList as a parameter. Save the file and let's go back to our ticket. And now we want to do something different. We won't only finish the areas which are still active. we don't want to finish areas which are already finished. So first, let's delete our for each loop and let's create list of ticket section with the name section with enabled scratching area, which will equals to section list, and let's create link statement where, and inside let's put a lambda expression, a lambda operator, a my scratch area dot game object dot active self equals true, and at the end let's write toList. So now we have a list of ticket sections which are still enabled, and then we want to run coroutines on them. So let's write yield return utility dot run coroutines all at once way to finish, and let's put this as a first parameter. And for the second parameter, we need to collect our coroutines. So let's use our section with enabled scratching area, and let's put select operator, and inside let's use another lambda expression. So let's write a lambda operator a dot my scratch area dot finish scratching, and let's put a dot board image list as parameter, and let's finish it with a toList. Save the file. Let's go back to editor. Let's exit our prefab. Let's press play. And let's start drawing. And watch, when we finish the section, we will see scratching finish animation. Let's watch it again. Nice. We see how smooth it is now to finish the scratching. Let's try it again. And it's working perfectly. Let's try it on these sections. And it's working exactly how we wanted. And that's also the end of this lesson. So thank you, and I'll see you in the next one. In this lesson, we will be creating winning panel animations. So let's open the canvas, select the winning panel and turn it on. And let's select our winning panel and let's create new game object. Let's change the name to be animations. And inside, let's create new game object and let's change the name to in. Now let's add anim clip player component on it. Let's duplicate it. Let's rename it to idle. Select again the in one, and we need to fill the animation object. So let's drag and drop our whole winning panel into the object variable, and let's choose scale up as animation. Let's test it. This is working. Let's check evaluate on enable, and let's also check play on enable. So when we turn on the winning panel, this animation will start automatically. Now let's select our idle game object. Let's change the clip size to be 2. And let's fill first object. So let's open our parent race and let's drag and drop our image race into the objects variable. And let's choose rotate 360 animation and change the loop type to be repeat and change speed to be 0.3. And also let's check play on enable. Now for the second object, let's open our parent button and let's drag and drop our button on it. And let's choose animations to be scale up and down. The loop type will be again a repeat, and that's everything. Now select database. Let's change the probability for our money and bonus to be 1 in all cases, so we can always see our winning panel show up. Now press play. And we can see it is working exactly how we want it. Let's do it for the bonus. and we see it works great as well. So let's exit the play mode. So now we would like to add some different animations to it. So let's select managers and let's open scoreboard manager. And here we need to create a new class because we want to differentiate our money part and our bonus part. So let's create public class UI part. And let's first store our TextMesh Pro variable into it. So let's write public TextMesh Pro UI count text. And inside our scoreboard class, let's replace our old variables with our new UI parts. So let's write public UI part main part and public UI part bonus part. Then let's go back to UI part and let's create system.serializable attribute so we can see the variables inside inspector. Now we want to fix the errors. So inside update money and score method, let's change our money score text to the main part dot UI count text, and let's change the bonus score text to bonus part dot UI count text. Now let's add different variables to our UI part class. And first we need public transform UI sprite transform, and second will be public anim clip player animation in. Then inside our scoreboard manager class, let's create new space attribute. So inside inspector, we will have nice separation after our UI parts. Now let's save the file and let's go back to editor. Let's open our managers. Let's select scoreboard manager and we can see we have a main part and bonus part. So we need to fill them. So first let's select our winning panel and let's turn it off. Then let's select again scoreboard manager and let's click on our left text variable. So the scoreboard hierarchy will expand. Now we want to fill UI count text variable inside a main part. So let's open our main panel and let's drag and drop text money count into the variable. And for the bonus part UI count text, let's drag and drop text bonus count onto the variable. Now for the sprite, what we want is use the transform of the image money sprite. So let's drag and drop that one. And for the bonus, let's drag and drop image bonus. And for the animations, let's select our main panel and we need to first create them. So let's create new game object, rename it to animations, inside create empty game object, and let's call it money in, add anim clip player component, select money in game object again, and let's duplicate it and rename it to bonus in. Now select money in again, and to fill our animation object variable, let's drag and drop image money onto it, and let's change the animation to be scale up and change speed to be 0.5. Now select our bonus in and let's fill our image bonus into the object variable. The animation will be same, scale up, and speed will be same, 0.5. Now let's select our scoreboard manager again and let's fill these animations. So for the main part, let's fill money in, and for the bonus part, let's fill bonus in game object. Now close the scoreboard, select our win panel manager script and let's open it. And here we would like to modify how we are updating the money score and the bonus score. So let's select our update money and score method and let's delete it. And at the end, we would like to add some animation to this update. So let's create if statement when we are asking if win settings.type equals to area type.money. And if yes, let's yield return new coroutine with the name panel finish animation, which will have three parameters. First parameter will be save load manager.instance.money old score. Second parameter will be save load manager.instance.money score. And the last parameter will be scoreboard manager.instance.main part. Let's generate this method. First, let's change return type to be IEnumerator, and let's delete the exception. And for bonus part, let's duplicate the line and let's change area type.bonus. Then let's add our bonus old score, bonus score, and bonus part. Now, to create this method, we need to create new list of iEnumerator called list of animation routines, which will equals new list of iEnumerator. Now we want to use our list of animation routines, and let's add some coroutines inside. But first, let's rename our main part parameter to UI part, and let's add our UI part.animationIn.play coroutine. Now to our list of animation routines, we would like to add a new method, which we don't have yet, which will be changing our score over time. So let's open the utility script. And here we will be creating a new coroutine, which will be changing the numbers gradually over time. So let's write public static iEnumerator change number gradually. And we need 4 parameters. First will be float from. Second will be float to, third one will be TextMesh Pro UGUI, but first let's add TM Pro namespace, and the name will be my text, and the last one will be float in time, and basically we will be changing our text over time from the from value to the to value. Now inside method, let's write float elapsed time equals to 0, and let's create a while loop where we are looping while elapsed time is less than or equals our in time. And inside loop, we would like to increment the elapsed time by time the delta time. And also let's change myText.text equals matf.floor to int, which converts the float to integer. And inside let's write matf.lerp with a from and to by our elapsed time, and at the end let's write toString. It's because the text needs a string type. To finish our while loop, we just need to write yield return null. And to finish our whole coroutine, let's write myText.text equals to toString. Save the file. Let's go back to our WinPanel manager, and let's add this coroutine to our list. So let's write utility.change number gradually. And now we want to fill parameters, but first let's rename our money old score to be old score and money score to be new score, so the method can be more generic. And let's fill the parameters. The first one will be old score, second one will be new score, third one will be UI part.UI count text, and the last one will be 2. Now let's run this list of coroutines with yield return, utility.run coroutines all at once, wait to finish, and put this as a first parameter and list of animation routines as a second, and wait in between, let's write 0.15 so they have slight offset. Now save the file. Let's go back to editor. Let's press play. Let's scratch our ticket. Our winning panel appear, and now look, our icon is growing up and also money are gradually increasing. Let's exit the play mode. Now we would like to create one more animation for our winning panel, which will be showing our price symbol and moving it towards our score multiple times. So for this, we need to create new game object, and let's change the name to price sprite with anim. Let's reset the transform. Let's add sprite renderer component. Let's choose our sprite. For now, let's choose the cloverleaf image. And let's also add anim clip player component because we would like to animate it. And we would like to animate the object itself. So let's drag and drop our price sprite with anim to the object variable. But for the animation, we need to create new one. So let's click on create button. Let's go to assets and animations, and let's rename it to fade alpha. Now add a property. Let's open sprite renderer and let's add color. Now let's open the color and let's remove RGB values because we only want to change alpha. And let's grab the timeline to last frame, which is 60, and let's change the alpha to be 0. You can see the alpha is changing. Now remove the animator. And let's fill the animation to be fade alpha. And we can test it, and it's working exactly how we want it. Now let's open prefab folder and let's drag and drop our price sprite with anim to it. So we create a prefab and let's delete it from our hierarchy. Now let's open managers and open a WinPanel manager script. Now at the beginning, let's create public game object variable with the name to instantiate. And at the end, let's create new method which will instantiate a game object. So let's write public list of game object, and the method name will be instantiate game object, and the parameters will be int how much. Second parameter will be game object to instantiate, and the last parameter will be sprite by sprite. And this method will create duplicate of our game object, and it will put sprite as a symbol. So inside let's write list of game object, my game object list equals new list of game objects, and let's create for loop from I equals 0 to I less than how much, and let's write game object myGO equals to instantiate, and the parameter will be our prefab with the name to instantiate. Then we need access to our sprite renderer component. So let's write myGO.getComponent of type sprite renderer, and we want a sprite from it, which will equals to mySprite. And at the end, let's add this game object to the list. So let's write myGameObjectList.add myGO. And to finish the method, let's just return myGameObjectList. So now we can have multiple copies of our prefab. Now inside our panel finish animation, let's create list of game object myGeoList equals to, let's use our method instantiate game object, and we want 4 of them. So let's put 4 as a first parameter. Second parameter will be our prefab with the name to instantiate, and the last parameter will be our WinType image, which represent either money sprite or bonus sprite depending on area type. So let's write WinType image.sprite. Now let's create for each loop where we want to loop over this myGameObjectList, and let's add to our list of animation routines one more coroutine, but first we need to define it inside our utility script. So let's open that one, and this coroutine will be moving our game object from one point to another point. So let's create public static iEnumerator with the name move2, and let's put first parameter to be vector3 from. Second parameter will be vector3 2. Third parameter will be transform, and the last one will be float in time. Now inside the method, let's write float elapsed time equals to 0, and let's create while loop where we are asking if elapsed time is less than or equals to in time. Now let's increment our elapsed time by time.delta time. And let's change our transform.position to be equals to vector3.lerp, and we want to lerp from to 2 by our elapsed time divide in time. And I see I make a mistake in our method above, so let's fix our lerp method also there. We need to divide it in time always, because in time can be smaller than 1, and then it will not work. Now let's finish our while loop to yield return null. And let's finish our method with a transform.position equals to 2. Let's save the file and let's go back to our WinPanel manager. And let's add this coroutine into our list. So let's write utility.move2, and let's fill from value to be item.transform.position. Our second value will be the UI part, .UI sprite transform. .position. The third value will be item.transform, and the last value will be time, how fast we want to move this object. So let's write 1.5. Now into our list of animation routines, we would like to add our alpha fading animation. So let's write item.getComponent of type animClipPlayer, and we want our play coroutine. And now when our newly created game object are moved to the location, we want to delete them. So let's create for each loop where we are looping our mygeo list. And inside let's write destroy and let's put item.gameObject as a parameter. Now let's save the file and let's go back to editor. Now select our WinPanel manager and we want to fill to instantiate with our prefab. So let's click on prefabs and let's drag and drop our price sprite with anim into the to instantiate slot. Now we can press play. Let's crash the ticket. And we can see our animations are working nicely. So let's exit the play mode. Last thing we need to do is to finish our database. So let's select our database game object. And first let's change probabilities for money prices. So first one will be 0.5, second one will be 0.25, and third one will be 0.1. Now let's do the same for our bonus prizes. And that's basically everything for this lesson. So thank you and I'll see you in the next one. In this lesson, I will show you how to build this game for a mobile phone, and in my case it will be Android. And first we need to fix our UI to behave correctly on our phone resolution. So let's select our canvas, and we can see our reference resolution is 1440 times 2560. So let's open our resolution drop-down menu and let's add new resolution. I already did it, so I will choose it. And now we can see our UI elements are completely changed, so we need to fix it. Let's open the canvas, let's select gameplay, let's turn it off. Let's turn on the main menu. And this one is working, so let's turn it off and let's again turn on the gameplay. So we have problem only with our gameplay. Now let's open our gameplay, select our scoreboard, and let's change our min anchor x to be 0, max anchor x to be 1, min anchor y to be 0.8, and max anchor y to be 0.95. Now let's zero out the positions, and we have a nice panel in the middle of our screen. Now we can see our number panel is rather squared, so let's open that one. Open scoreboard, open aspect fit, and open panel number, and also parent. Now let's select shadow, fill, and edge, and let's change pixel per unit multiplier to 0.70, and we see we have again round number panel. Now close the scoreboard, select our ticket holder, and let's change anchors to be min x 0, max x 1, min y 0.1, and max y 0.75. And also let's zero out the positions. Now let's open our ticket holder. Let's select our 3 tickets, A, B, C, and let's change the anchors to be stretched. And we see now it's working nicely. Now let's select our ticket B and let's turn it off. Let's open our ticket A to check it if it's work, and we can see it's working nicely. And now let's select ticket C and let's check this one. And this one we can keep like this, or we can make it more squared. And what we can do is just to add aspect ratio filter. Let's change aspect mode to fit in parent. And let's change aspect ratio to be 1. And now it's more squared. It's only subtle difference, but I like it like this more. Now let's select our winning panel and let's turn this on. And for this one, we don't need to change anything because it is working. So turn it off again. And now basically our game is ready to build. So let's save the scene first. And then let's go to build settings and let's select Android and let's click on switch platform. And now all the textures and everything scripts are compiled to the platform. It will take a while, so I make it faster. Now let's clean the animation folder. So let's select it and let's select all the controllers and we can delete them. And now we need to do a very important step. When we want to build our game, our animation needs to be in a legacy mode because our AnimClip player works only with the old animation types. So let's select all the animations. Let's go to the inspector and let's turn on the debug mode. And let's check the legacy mode for them. And let's turn off the debug mode. And now our animations are fixed and they will work also when we build our game. And to build our game, we just need to press build settings. We need to plug our phone and just press a build button. Now let's change the final aspect ratio to be our 1440 times 2560. And we can press play to test it. And it should work the same as on our phone. So let's scratch a couple of tickets. And it's working perfectly. So let's exit the play mode. And we almost finish our course. So let's thank you and I see you in a bonus lesson. In this lesson, we will be creating initial scratching animation. So first, let's duplicate one separator and let's move it under our database. Let's create new game object and let's rename it to initial scratching. Let's reset the transform. Inside, let's create new game object and let's call it vertical movement. Let's change the icon to be red dot so we can see it in inspector. Now let's select our initial scratching game object and let's move it a little bit to the left so we can see the dot. Now let's select our vertical movement game object and let's create new one and let's call it horizontal movement. And let's change the icon of this one to be blue diamond and change the position for the X to be -10. Now let's zoom out a little bit so we can see both of game objects. Now under horizontal movement, let's create new trail game object which is under the effects. Let's select it. Let's change time to be 999. So basically the trail will not fade out, it will stay. Then change min vertex distance to be 0.001. Let's change the color to be red for the beginning and the red for the end. Now let's change the corner vertices to 10 and end cap vertices also to 10. And for the material, let's choose our old solid color one. And we want this trail to be visible only on the scratching layer. So let's change it. Now when we select our initial scratching parent and when we move it a little bit, we can see we are drawing basically the line with the trail. And to delete it now, we need to select our trail and let's change our time variable to be 0 and let's put it back to 999. Now let's select our initial scratching game object and let's create new one. Let's rename it to animation and under it let's create new game object and let's rename it to in and let's add AnimClip player component on it. Now let's duplicate the in-game object 2 more times and let's rename the second one to idle and let's rename the last one to out. Now let's select in-game object again and we want to fill our animation object variable. So let's drag and drop the vertical movement onto object variable and for the animation we need to create new one. So let's select our vertical movement game object, and let's also move our animation panel to the lower side of the screen. Let's create new animation and let's change the name to vertical movement. Let's add property, and the property will be inside transform and inside position. Let's open it. Now we don't need the Z values and X values. So let's select Z and X keyframes and let's delete them. And for the Y value, let's move the timeline to the last frame, which is frame 60, and let's change the value to be -17. And when we scrub the value, we can see how this will be moved. Now let's ignore the trail, we will fix it later. Now let's delete the animator because we don't need it. And let's select the in-game object and let's change the animation to be vertical movement. And let's check evaluate on enable. And let's change the speed to be 0.5. Now let's select our idle game object, and for this one let's drag and drop horizontal movement game object into our object variable. Let's select it and let's create new animation with the name horizontal movement. Let's add a property, open the transform, and let's add a position. Let's delete the Z and Y keyframes because now we want only the X. Let's move the timeline to the last frame and change the value to be 10. And now we can see the value is oscillating between -10 and 10. Now we can delete the animator. Let's select our idle game object and let's change the animation to be our horizontal movement. And also let's check play on enable, and also let's change a loop type to be ping pong. The value will be ping ponging between -10 and 10. And let's change the speed to be 7. Now for our out animation, let's first select our trail game object and let's create new animation and let's rename it to trail size up. Let's add property. Inside our trail renderer, let's add parameters width multiplier, and let's go at the end of the timeline and let's change value to 5, and we can see the width of the line is growing. Now we can delete the animator and let's click on our out animation game object. Let's fill the trail into the object variable and let's choose the trail size up as animation and change speed to 2, and we finished our animations. Now let's go to our animations folder and let's clean it a little bit. So select all the controllers and let's delete them. And now select our 3 animations which we created in this video. And let's turn on the debug mode and let's check the legacy because our anim clip player only works with the legacy clips. Now let's turn off the debug mode. Now we need to position our initial scratching game object to the right position. So let's select our initial scratching game object. So let's change the X position to be -6.5. Y position will be 6.5 and a Z position will be -5. We also want to change a rotation to be in 45 degrees. Now let's click on trail and let's reset the time to 0 and then to 999. So we have clear viewport. Now let's open the canvas and let's create new UI image because we want to scratch something. And let's rename this image to initial BG. Now let's change the color of the image to be black. And let's also make it stretchable and change the position to be -4. Now let's go to our rendering folder. Let's open the material and shaders, and we need to create new material. And let's call it UI initial scratching. And let's assign from the shader graph folder our UI scratch shader. Fill the render texture with the scratch render texture, which we are using in all our scratch images. Then let's change our edge width to 0.01. Let's change edge color to be white. Change vignette scale to be 0. Vignette intensity to be 0. pattern opacity to be 1 and pattern scale to be 0. Now let's select our initial BG game object and let's pick our material. So let's choose UI initial scratching. And let's don't forget to change the alpha value for the color to be 0. So our scratching will be visible. And also let's add aspect ratio filter and let's choose aspect mode to be envelope parent and let's change the ratio to be 1. So now we have big square image. Now to make it work, we need to add this animation to our gameplay loop. So let's open our scripts folder, select our managers folder, and let's create new C# script. And let's call it start sequence manager. Let's open it. Let's clean the file. Now we want a static reference to this class. So let's write public static start sequence manager instance. And in awake method, let's ask if instance equals to null. And if yes, our instance will be this component. Now let's create public anim click player with the name anim in. Select the line and copy it 2 more times. And change the second one to anim out. And the last one to anim idle. Now we need reference to our background game object. So let's write public game object initial BG. And also we need reference to our trail renderer. So let's write public trail renderer trail. Now let's create new coroutine. So let's write public IEnumerator start sequence. And inside let's write initial BG dot set active to be true, because we want our black background to be visible at the first. Then we want from our trail to start emitting. So let's write trail.emitting equals to true. Then let's write yield return anim in.play. So we are playing the horizontal movement animation. And also after anim play stop, let's write anim idle.stop playback. Because if we doesn't stop it, our idle animation never stops. The last animation will be anim out. So let's write yield return anim out.play. And the last thing what we want is to stop emitting from our trail. So let's write trail.emitting equals to false. And also we want to clear our trail. So let's write trail.clear. And the last thing will be to disable our black background. So let's write initial bg.setActive to be false. Now let's save the file. Let's go back to editor. Let's open the managers. Let's create new game object. And let's rename it to Start Sequence Manager. And let's drag and drop our Start Sequence Manager component on it. Now we want to fill our values. So first let's fill the animations. Then let's fill our initial BG and also our trail. Now let's open our game manager. And let's write one line, yield return start sequence manager dot instance dot start sequence. And that's everything for it to work. So let's save the file and let's go back to editor. Let's turn off the background so we don't need to see it. And let's press play. And now we can see we have nice initial animation of scratching. Now we can enjoy our game. And I hope you like this course, and I'm looking forward to see you in the next one. So thank you and have a nice day.